of big time software. So, mobile revolution changing the IT world. This is true not only for Delphi developers, particular customers and so on, but for probably all the users and developers all over the world since more or less 2007, 2008. And this there are many considerations that can be done. The first one is that there is a different way to do the same things, because the mobile changed the way you usually do some things from 10 years, 20 years. Mobile completely revolutionized the way to do some things. There are new problems to do the same things, and the mobile environment is not simple as desktop. You cannot say, okay, my PC is in landscape, I don't want to use my PC like this, so it's a landscape. Or there is no multiple display density. I have 72 dot per inch, that's it. Or there is not limited connectivity. If your application doesn't work, because there is not connectivity, you can say, there is not connectivity, it doesn't work. That's it. But in mobile side is not as is. Then your device are powerful, very, very powerful, but as not powerful as your PC. So there is also limited computing power involved in this kind of development, and limited battery power. You have to take care also of the energy or the electricity that your app could drain from battery, and many, many, many other things. So, mobile environment is not simple as desktop at all. In this speech, we try to talk about specific problems that are very popular when you develop on mobile. So we will talk about problem, solution, using the code, demos, to address specific problem. I don't know, 5, 6 problems? How many? 5 problems. Okay. The first one, don't block user interface. This is the scenario. You have your user in some fantastic land near here. They want to use your application, try to tap it, but the network is low. Or the network could be slow in some cases. So the server reply when he has time, or could be too busy, or could be whatever. Your application is blocked to wait, is blocked waiting the server response, and you get an application not responding error, or simply the application is closed on iOS. Because if there is not an error message, it never happened. So heavy or long operation can block the user interface thread, and this is a problem, especially in mobile environment. If you have your desktop application that is waiting for 1 minute, 2 minutes, 3 minutes, some users could complain. But on mobile side, if your application is blocked, is not responsive, is not alive from the user point of view, the situation is this app doesn't work. How many times happens that you are some customer asking you, your application is blocked, your desktop application is blocked, but the real problem is that the application is doing something slow? Is it happen? Someone? Yeah. Okay. Let's check what could be happened. If your application is private, so you sell to the customer directly, the customer could complain, this app doesn't work, and so on. If your application is on the market, the situation is even more worse. Because the many customers could vote negatively your application. So this app sucks, force close, 1 star, doesn't work, uninstall. You don't know which kind of connectivity situation this user had. Solution: execute EV operations in the ground thread, keeping free the main thread to do its job with the UI. Okay. Multithreading can be complex, but for simple scenario, there are simple solutions. And there is an interesting sample project shipped with Delphi called cross-platform utils. There are a lot of code and units that take care of different situations that could happen on mobile and also on desktop, especially on mobile, regarding some situation specific. The first demo use this class from the cross-platform utils project to don't block the user interface while it's doing a heal request. The second demo show also an please wait animation to inform the user there's something that's going on. Okay, Daniele.
Okay, in this application we have 3 buttons. One of these block the UI thread. So we see can the UI thread is blocked, and after, in Android specifically, after 5 seconds, show a message that the application isn't responding, like the previous line. Yeah. In this, under the button click, we simulate a request that simulates an heavy operation over the network, for example, for download a list of contacts. But in reality, we have a slip of the thread for simulate this operation. The other 2 buttons don't block the UI and use the first an anonymous thread that is a class that is present in the cross-platform utils, and the async progress. The difference is that the async progress show a dialog message for show something to the user. Okay, let's go to the demo. Okay, yes. This is the T-anonymous thread class that we use generics. So we...
Can you a bigger font, please?
Okay, better? Okay. Use generics and expect 3 parameters and a thread function that return the type specific. So when we must return the type we have specified, and the other 2 is the unfinished request. So when the request has done what we can do, and the other parameter is the procedure if the request raises an exception. And the request is in a separated thread, while the other 2 is the safe thread and sent and work on the UI thread.
So the trips is that the first anonymous method is your actual thread. and runs in a background thread. Then, when something happens, that could be the thread finished or some exception is raised, the other anonymous method is called. And these two anonymous methods runs on the main thread, so you can safely update your user interface from these two anonymous threads, but not for this one. This parameter defines which is the type of the result of the anonymous method thread, which is also the input parameter, so the return of this function will be the input parameter of this other anonymous method. Or, if an exception is raised, the exception raised will be the input parameter of the third anonymous method. So this mechanism is not usable for every kind of multi-threading, because multi-threading can be really, really daunting. But on the simple situation or most popular situation, where you have to issue a request, do something, and then update your user interface, this simple structure can be really, really useful. The ITDevCon application, for example, one need to download all the information about speech, speaker, sponsor, and so on. Use this mechanism to don't block the user interface.
Okay. And this we can see on the phone because the the device is small, but we can see this demo on the device because the RAD screen is slow, so we can capture the animation. Okay. 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 If we click the block with thread, we can see that the user interface is blocked, and after 5 seconds, the application shows the message isn't responding. Okay, this is bad for the user, but after it's complete the operation, and we can see the list. The other button, don't block UI by anonymous thread. We can see in background it works, and we can move the button, for example.
Or do something else.
The third button using the TS in progress and show a message while the operation is working. When finished, show the contact list.
Okay. Have you understand how the anonymous thread, anonymous progress works? With the 3 anonymous methods, the first one in the background thread, and second and third one on the first thread?
There is no way to get partial results. The method calls the function only when it finishes the task.
You need some progress, 100%, 10%, 20%, 30%. Yes, you can, using another anonymous method inside the thread, the background thread of the anonymous method. Let's see the code. Here, you can write tthread.synchronize or .q, and then pass an anonymous method, which will be will be executed on the user interface thread. The difference is that you can use thread. No. Synchronize. If the first parameter is nil, then the thread where the second anonymous method will be executed is the main thread. So you can you can calculate your percentage here, and then use an anonymous method to update the user interface for progressing the reason. 10%, 20%. Okay? So you can, yes. Other questions? Bye. Then the second most deepest problem is the multi-resolution image problem. On mobile, you have to take care of resolution of your resources images. Why? Because a FireMonkey mobile application could run on this device, or this device, this device, or this device. So if you have an image, let's say 100 pixel for 100 pixel, that image will be like this on a smartphone and like this on a tablet with the same, let's say, with the proportional density of the display. And this is not your target. Because let's say that you need an image that covers the half upper part of the display on smartphone. On tablet will not be, because you can cover only probably a quarter. So the resolution is different. Why? Because, not because you have different resolution, but because you have different display densities. Densities means is expressed in dot per inch. So means number of the point in a physical measure. So a lower density have a lesser number of points in 1 inch. A higher density have a higher number of points in the same inch. So you cannot have one image that fits all densities. It's not related to the size of the display. You can have a smartphone that has the same density of the tablet, or a low-end tablet, okay? Or even higher than tablet. So if the density is 2x regarding the image, then the image should be 2x bigger. Let's say the demo. There is an interesting property in the new T-image component that is called multi-resolution image. Let's check the design time property editor for the image. Go to multi-res bitmap. Vai su multi-res bitmap. This property, multi-res bitmap. Click. Okay, here you can load all the different scale image for the different density display. So you can define the image itself, but also the scale that cause that image will be used. So I can define scale 1 will be used this image, scale 1.5 will be used this image, 2 will be used this image, and 3 will be used this image. So your T image is actually a T images, because you have different version of your image. Let's see the application of the code.
this application code is very simple because I bought the image component on the form and assign at the multi-resolution bitmap every scale. This is because Delphi support for Android 4 types of scale: 1x, 1.5x, 2x, and 3x. That corresponds the small screen in Android, medium, large, and extra large. In iOS, there is support for non-retina or retinal display that correspond the 1x and 2x scale. So we have two phones with different density. This device, the Galaxy Nexus, have 2x density, and this HTC1 have 2x density. If you can see, use a different image, but I see the same thing. So I have support the multi-resolution.
So you have the same proportion, the same physical feeling about the image size, but you actually using two different images. That should not be the same image. When you try to create the image that will be used, you should not take the 1x image and stretch it, obviously. But you have to create a different image with double point in it, okay? So this is really simple. Delphi take care of all the stuff regarding the scale and so on. But the things getting a little bit difficult when you have this kind of situation. In many kind of application, usually games, but not only, you can have a tile image with all your piece of the image inside it, just like sprites when you develop a game or so on. This is used also on website as a mechanism. When you have only one image that downloads all the images used by the page, and then by CSS you try to cut the specific image to use in button images and so on. Why? Because you, in a web environment, you can do one request and not 10, 20, 30 requests to the server. On mobile, is useful because it's faster to load this one respect to 30 small files, and it also allows to avoid the file fragmentation. So you have only one file, and your graphics department will be happy to create only one file, and you can cut piece of the image using only that piece in your application. The hint is to dispose images in a logical way, so you can use a simple algorithm to cut it, because you could have an index of the image from 0 to, I don't know, 19, but you can also have complex things like this. This comes from games that we developed in Delphi. Will be the first games developed in Delphi on Play Store. And the mechanism here is about row and column. As you see, the first row have the upper tile with the lowest number, so it's 0, 1, 2, 3, and then the column defines the lower tile, so 0, 1, 2, 3, and so on. So you, with a simple mechanism regarding coordinates, can cut the interesting piece for you. Let's see the demo.
Okay, in this demo we have two edits that represent the value up or value down for the specific tile that we have to cut in the image, and we have on the form the image's resources, that is the big image that we have seen on the slide that represent our resources. Another image is the image that we have to cut. So when I want to take the image, I get the scene scale that represents the scale of the current device where the application is running, and get image rect is the algorithm for cut the right image. So the top is by value up for tile 8 for scale, value down left value up for the left image. Okay.
Show how you cut the image and write to the other image.
Ah, yes. Okay. For draw the image to another, we can do this this code. We get the bitmap from the image tiles that represent the single tile, set the size, the relative size. We can call the canvas.begin scene to begin to draw on the canvas. Draw bitmap that is defined from the source rect, depth rect, that is the rect of the resources image and the single tile, and then we call handScene for draw this on the canvas.
FireMonkey is built on mobile, is built on OpenGL. So there is a set of methods that you need to call different from VCL, standard VCL, to start to draw on a canvas and actually draw on that canvas. If you try to write low-level OpenGL or DirectX code, you will see that you have you wrote always on a in-memory bitmap, and then when you want to actually show to the user what you have drawn, you have to call flip. So you draw always on an in-memory bitmap, and then at the end, flip, flip, flip. This is the flip. And this is the way in which you tell to the FireMonkey, hey guy, I want to write on this canvas. Okay? If you don't write begin scene and end scene, you don't see nothing on your canvas.
So, if we want a specific tile, we insert the value down, for example 0, and value up 0, click on take image, and we can see that I cut the relative tile, sorry, on the image's resource.
0 is 0 is too much simple.
Yeah, can try 0 and 6, or 6 and 6. 5 and 6.
Okay. Yeah, pull the combination. Okay.
And this is also this demo is multi-resolution because we have the same the same demo on this device that is 3x scale, and we have the same result. You can see on
with the same
device.
physical sites, you see the same site image. Okay.
Okay.
Questions? No? Is enough simple? Go. Okay, application life cycle. This is an interesting mobile-specific problem. Let's say that you are using your application, you're doing something or your customer is doing something on your app, and then incoming call. For a phone, an incoming call is the highest priority events. He cannot block your incoming call because you are going to write the description to your customer. Okay? So this is the higher priority events that can happen in mobile phone, but it's not the only one. It's probably one of the most probably, but it's not the only one. This is the problem. Now your app is in background, probably in the middle where you will write your data. And when an app is in background, is going to go in background, the operating system, iOS or Android, but even more on iOS, could be destroyed without events. Can be destroyed, that's it. So, the user, when the incoming call ends, could get back to your application that is empty. Or your data that are not actually saved somewhere will be lost. Why? Because the operating system has simply dropped that application. This can or cannot happen, but is not in your, you cannot decide it, because the operating system decides which kind of operation do on a background application. It can decide to drop it or not. The solution, the FireMonkey service framework, that is a simple object locator design pattern, does a good job in abstracting the platform-specific behaviors. And in the Unit FMX platform, there is an interface called IFMX Application Event Service that makes it possible to register an event handler for to receive specific lifecycle events. These lifecycle are application lifecycle, are not form activate, form close, and so on. Are application lifecycle. But we are interested in application lifecycle, not in form activate and so on. In those events, you can handle the situation. This is the different lifecycle that that are implemented in Android and iOS. To be specific, this is an activity lifecycle. It's not application lifecycle. But for Android, each activity is more or less a small application. So, as you can see, because Android supports really background application, the life cycle is a little bit complex. On iOS, it's more simple because the background state is is a more or less a dumb state, so it's a little bit simple on iOS. Let's say the life cycle demo, but the nice things to see here is that you can use the same interface, the same service to handle completely different situation with the same code. Let's see the demo.
Okay. This demo work on iOS and Android both, but we can see it only on Android, but work also on iOS. Well, remember it now. Okay, this is the platform services. Okay, the first thing to do is check if the platform supports these services. So, if the platform supports the application event services, we can set the application event handler. Set the application event handler is a method on the form that handles the application event. This is the case of an app event, so on finished launching, available only on Android, that is called when the application is finished launching, became active when the application is in foreground, so it's visible and the user can interact with it, and will become inactive when the application is in the foreground, but the user can't interact with it. So there is a dialogue on the activity. Enter background when the application is not more visible, so is in the background, and will become foreground when the application become in the visible state. I will terminate when the application will terminate. Low memory, time change, overview are explicative. So there is a low memory when the time change when a URL is opened.
So the trick is to find which is the event, the application event that we have to handle to do something on our middle state, on our transition. We could do save on the file to the data, or you can post on the dataset or data bind source or whatever. The data, or you have to decide what means for your application going in background on every possible state. So when you write your application, you have to ask yourself, what happened if in this moment the application go on background?
Okay, the application is finished launching and became active, and we can see the log on the form. So it's finished launching and is in the foreground. If we click on show message, a message is displayed, so an hello world, and the application will become inactive, so the application is yet in the foreground, but the user can interact with it because there is a message, and will become inactive. When I close the message, the application became active. If I press the home button and then return on the application, we can see all the application events. So will become inactive, entering background because it's not more visible, will become inactive, will become foreground because the application is returned in the visible state, and then at the end became active. So it's the foreground and I can interact with it. Another difference with the specific Android platform is that I rotate the phone, no events is raised. But in Android, if I change the orientation of the phone, the activity was destroyed and recreated.
This is probably the main different things between the FireMock implementation and the standard Google implementation. When you rotate your device on Android, your activity will be destroyed and recreated, always. While on FireMonkey, you don't get lost the state of your form, but you could lose the state, obviously, if your application is dropped. Obviously. So this is a good thing to handle, to know when you comes from an Android specific skill, let's say, but you have to handle the application that goes on the foreground, on background. Okay, next one, multi-interface. This is a little borderline, because Embarcadero actually have a solution to this problem, but in the Quality Central there are a couple of bugs that say, hey, this doesn't work. So this is the solution for this kind of problem. Let's say we have a form designed to be portrayed with some nice big button with a thumb on it, button 1, button 2, button 3, then rotate your device. And button 3 is getting lost. This could be also, you could say, I put the correct alignment, okay, but a piece of your form is not more visible. This is really a big problem on the mobile device. Can be work around it if you block your application to be only portrait or only in landscape. Let's say some games start in landscape and that's it. There is not the portrait version because it doesn't make sense. But in business application, you probably need to not only handle this situation, but also change the interface, the user interface, when you are from this one to this one. Probably your user put the device in landscape when he needs to write text, because it's more simple with 2 fingers. While normally it's used this way, because it's simple to choose from the menu, isn't it? Okay, the solution. This is not officially supported, but it really works. There is a demo for Embarcadero, but it doesn't work well like this. So, the solution is to use a sort of model to contain the state of your form. So, do you remember the MVVM talk of Jerome yesterday? This is the common approach. You don't have you should not put the state of your application or your form on your form. Your form should not contain state. In this case, we are using a sort of model. In this sample is a data module to contain the state of our form. And then we can handle the on resides or orientation change it, but it works in different ways, so we can use only on resides to know when the device has been rotated. Then you can use live binding mechanism to automate the rebinding of the data. And you could also use get device form to get the correct form for the situation based on resolution and some other things. But this is normal Delphi code. There is also demos that show this get device form. This is the part complex, where a simple property on a form cannot help you. You have to separate your data from your display visualization. Okay, we show the basic technique using the simple form factor demo.
Okay, in this demo we can see a form when the application is portrait and another when the application is in the landscape.
Sorry, show directly the demo. That is simple to understand.
Okay.
case is, let's say, a traveling seller that needs to rotate the device and use a completely different user interface, adapted for landscape position, orientation, or portrait orientation. Completely different. We're not talking about stretching, alignment, no, completely different interface.
Okay. So, like the slide showed previously, if I rotate the device, I could lost some edits. In this case, the portrait, I can click on Save for Hello Portrait. If I change the orientation, I change also. No, okay. There is another layout, so the edits are disposed in a horizontal way, and the Save button in the center. And see if I click Hello Landscape.
So see, the interface is completely different. It's not adapted from the portrait version. It's completely different. Okay, let's see the code.
The method that we intercept is the form resides. So where is an application in landscape or portrait, if the width of the form is greater than 8, the application can go in the landscape form. So we create the landscape form and show the form, and hide the portrait form.
Take care that we here here there is a hide, because on Delphi, if you close the main form, the application is closed. But if this is a secondary form that you can actually close it, because you see the results. No, your user interface, only user interface, because the data that you see on the user interface are not on user interface. You see them, but are not there.
No. The data are
on the model.
Yeah.
So all the logics, all the machinery, all the mechanism, all the business logic, whatever, is on the data model, not on the form. If you put your logic on the form, you will be tied to that form ever. Always. Okay? Forever is there. Okay? So this is the thumb rule. Don't put your logic on the form. Never. Okay. This is the simple application. Let's see the more complex one that have another times completely different user interface that does more complex things.
Okay. In this demo we have a list view with some contacts, and when we change the orientation and enter in landscape mode, we want to edit the selected contact. So
this is a completely different way to use the application. So the user don't have to tap, do something, nothing. Put it on landscape and start to edit.
Yes. So if I click on Adam Brown and change the orientation, we are on the edit mode, and we can modify the title and the contact name. So, if for example we modify brown add some T and retard in portrait mode, we can see the change. So, okay, we can see the change.
Using a shared state between the two forms can also maintain the state of the binding source, So you can change the form that actually show your data, but don't change the state and the values related to that data. This is the reason because when you change the orientation, the state on the list is maintained. Okay?
Also interesting is if I create another contact with title and contact, I don't click the post button, but I turn the phone, I can see it on the list.
But it's not posted.
No.
No, because the data source has not been confirmed. But if you return on the landscape, you can start to edit other ones.
Yes.
Okay? Okay, go over. We are short time to. Okay, good. Okay, this is the most articulated demo. Accessing remote data. Some of you are interested in accessing remote data? Okay. This is the accessing remote data scenario. You have a mobile device, a server somewhere in front of your database. Your mobile is accessing using HTTP on REST or whatever REST to your server. There are a set of well-known problems. The first one, retrieve data from your remote server. We talk about retrieving, thread background, and so on. Then integrate, this is the normal scenario. Gets data, integrate, update, delete, do something. Post your data locally, so you are not tied to the actual connection. So save your data locally, and then send changes to the server where the connection will be available. This is the normal pattern to do this kind of things. How to structure this application? Let's see a demo, because it's difficult to talk about it. It's more simple to see it. The server is the MVC framework server that acts as a REST server, provides data and facilities to store on the database your integrated data. The data accessing layer is a DORM that could track all the machinery related to new, changed, deleted, and so on. So the code, the application code is really, really simple.
Okay. The client application is a form with an at beginning a to-do list. So I add a to-do, and then I can synchronize the data locally on the device with the server. So the add button had my to-do, and refresh button is for get the new information from the server, synchronize to put the information that I have changed or create on the server. So the first thing is to refresh the list of to-do. I can see Baekar, Hola, and Pluto. So if I add a new to-do, hello, and and click the synchronize button, I send the new information to server. There is an indicator to see that the application, the request is running, but with the screen response code. Okay. So if I refresh the list, I have the hello that I secure that the new information has passed on the server.
The client have to handle the state of your record. So this has been inserted, this has been changed, this has been deleted, and so on. On the server there is Norm that can track this one, but on the client no.
Yeah, so the refresh I have used, on the refresh I have used the T-anonymous thread, and I do the get, that is a call to the server to do. This is the REST client, a library, a framework for me that is inside of the MVC framework, and then I'm mapping the list on a JSON object, and then I can do the result on the form by refresh list. Okay.
Wait, back to the mapper. These 3 rows do really complex things. This gets the result, the REST response. Then this gets the body of the response and try to parse it as JSON object. Then gets the property to do's and cast it as JSON array. This is a JSON array that is getting to be converted by mapper, that is a sub-project of the MVC framework. Map this JSON array to a list of T2do. So the current list becomes an object list that has been actually read from the server.
Yes. The path, the put, create a JSON object and put in the object list all the elements that I have on my list on the form. So with the do put command, I can I send the new information on the server. It's 3 lines of code.
Yeah, and in this way you can save a collection of data. Because on the server the user could be add 1 row, update another one, delete another one, and using these mechanisms you can automatically save, or better, persist all the changes to your data. Let's see the DORM part, DORM interfacing part. This is the actual controller of the server, and you on the get all to do, the code is simple, go bottom. Okay? This is simply load list, and then random list is property to get all. This is the DOM session, bottom. Then there is the get the single to do, if you need it, bottom. And then here there is a mechanism to check if the data is valid, and then gets the mapper as JSON array, map it to a T-object list, and then persist collection. That's it. Okay? Good. Are there... This is a fast tip and tricks that you can find somewhere. Are there any questions?
Multi-language? About multi-language on device to manage Italian?
There is the T-lang component from the FireMonkey platform, but the good thing is that the language you can set a startup and that's it. You could also change the language if you want. I don't know if Italian speaking is a landscape and you speak in portrait. I don't know. Could be. Could be. There is the T-lang component that actually works for this kind of things. Other questions? No? Good. Okay, thank you. on X. Don't you hate mobile stuff? Yes. Come on. My mobile phone just rebooted. Yes. Connect to Windows. Hopefully it'll work. Okay, good morning everybody. There's been tons of mobile stuff already on the conference. So I found out that Marco yesterday did about 70% of my slides. And I know Daniela did a lot of this this morning. So we'll make this a bit flexible. I'll give some demos. There's lots of room for discussion. I will focus mainly on Android stuff because the iOS stuff has been in Delphi for quite a while now, and about how a sample application, a very simple sample application that works in VCL, FireMonkey for Windows and Mac, and on FireMonkey for Android. It could work on FireMonkey for iOS as well. I don't have an iOS device with me, but I have a Mac as a host, and I have Xcode on the Mac, so I can run it in the emulator there, just to show you guys a couple of things. And I wanted to talk about stuff that you guys should not do when developing software. I borrowed the main slide deck from Pavel Glowacki, who did a big part of the European XE5 tour, which overlaps quite a bit with the slides that Marco showed, but also has a couple of unique stuff in it, which hasn't been shown already. And there's a couple of things of the slides that Marco already showed that I want to put a couple of more highlights on. If you have questions, just interrupt me, wave at me. I have a slight problem, my left ear doesn't work, so if you start talking without waving, it's a bit difficult for me to see where you are and really understand you. I don't understand Italian, so please keep everything in either English or German or Dutch, and I'll translate it to English for the rest of the people. So any people having questions at the start? Good. Let's pop through a couple of things. Polish, which I don't understand either. But luckily, the rest is in English. The message is clear. There's 1 billion mobile devices. There's still a billion Windows devices, so there's lots of Windows work. But given how people use their stuff, where's that slide? Well, over time, people are using desktop machines at work, but when going to work and coming from work and being at home at night, they start to use more and more other devices. So it makes sense having at least part of your software run on mobile devices. And I wanted to focus on a couple of things that Marco hasn't told, which are very important to realize before you even start thinking about doing mobile work at all. So the top 5 mistakes you can make. Do not try to fit your desktop application on a mobile device. Repeat, do not try to fit your desktop application on a mobile device. This is what every developer starts doing when he moves to the mobile world. Oh, I have this great desktop application. Let's put the whole thing into a mobile application. My example is tic-tac-toe. Is there an Italian word for tic-tac-toe? Did
the English also use lots of crosses. It's a very simple game. You put crosses and zeros. The first one having 3 in a row wins, right? Very simple game. And this is excellent to move to the mobile world because the user interface basically is this. This will fit on anybody's smartphone, even a smartphone from the 90s with this very tiny screen. It's basically 9 buttons and a couple of settings, and the settings might even be on a different screen. So screen estate on a mobile device is important. People have big fingers. That's the other drawback of having only one ear. I can't hear directions, so I heard this strange sound. And apparently it's a church somewhere. For me, it sounds like there. I'm not sure where it is. It's outside, I know for sure. Okay, so mobile devices are tiny. Tablets are relatively tiny as well. They don't have accurate pointing devices. They have a touchpad, but it's not very accurate. So be prepared to have big buttons and not much information on the screen. A mobile device usually is between about 30 and 50 centimeters from a person, which is a different distance to what the monitor is from a person. So you need to make sure that you adjust font sizes, colors, etc. There's even this very nice thing going on the internet that you should not use black and you should not use white. You should use almost black and almost white in order to play with contrast and be able to bring over emotion, because a black that has a taint of red has a complete other feeling than a black with a taint of green on it. So there's all sorts of things on the user experience part. And Jörn will give a talk later today having to do everything to do with user experience. I think it's titled "Don't Be That Freaking Moron That Wrote This Application." And the title doesn't completely match the content, because the content is in large part about user experience. So that's an important thing to reckon. Do not fit. Mobile devices are a completely different beast than desktop devices. And even between mobile devices, there's a big difference. And it's one of the reasons that inside Delphi there is this way of switching between font sizes from here 7" at the bottom, but it goes further than that. It goes to 10" and you can add your custom device, which means that when you start developing mobile software, you will have multiple forms doing the same thing, because on one device you will show this form and on the other device you will show that form. That's especially true when switching between mobile phones, say small mobile devices, and tablets, say big mobile devices. Another thing which I won't cover at all, but which you need to think about later on because it's more advanced, is that mobile devices use both touch, like a mouse click, and gestures, like swipe and stuff like that. And swiping has become, especially over about the last year and a half, a very important feature on not only mobile devices, but also on, for instance, this Mac. I can swipe this trackpad and switch to my Mac view of things, and I can swipe the other way around, and I get back to my Windows virtual machine. So this is a thing that started in the mobile world and is slowly making its entrance into the desktop world. So in a year from now, you'll see all kinds of desktop applications doing lots of things with gestures. And the cool thing is, gesture support has been in Delphi VCL since about 2007 or something like that, and multi-touch support. So even on the desktop side of Delphi, you can use that. So the important thing about mistake number one is that you need to be aware of where your application will run and what kind of users there are. In a sense, it's not much different from what you should do for regular desktop applications. I know quite a few applications that have a starter mode for people that start using their application and an expert mode that contains a lot more features for expert users that use the application every day for like 4 or 5 hours a day for the majority of the work. So the simple user experience is for users that use it once or twice or 3 times a day, and the experience user interface is for users that use it all day long. So when developing an application, you need to be aware of what kind of user groups you will have, what kind of devices they will use, and how to best match the user experience with the use case that the users will be using. And that's difficult. Marco had this yesterday like 5 times, didn't he? Let's see. Cool. Okay. Are we cool? Do we have a network? I don't think I need a network connection at all for this session, by the way. Okay. Anyway, so being aware is very important, and it's becoming more and more and more important. Which means that interaction designers, user experience people, actual user interface designers are becoming more and more important in a project. And that's one of the grounds that I did the session yesterday about MVVM. Since MVVM doesn't work on mobile devices yet, my example doesn't use MVVM, but it makes it much simpler to split your business logic from your user interface. So we'll get there towards the last half of the presentation. Okay. Work with templates. So if you have decided about your user groups, make templates for your forms for certain kinds of devices and use those templates actively in your applications. Because that gives the users the feeling that they recognize how your application works and that there is a kind of structure throughout the whole application. So if you have like 6 or 7 forms that perform similar tasks, they should look the same, and you should use a basic template for them to make them familiar with your software. The mobile user experience is different. And actually this is one of the things where FireMonkey might make it more difficult for you if you don't think about it in advance. An Android device has a different user experience than an iOS device. For instance, menus being at the top or at the bottom, swipe actions working slightly differently, the starting experience being different, which means that if you are going to deploy an application to a broad user range, say regular end users, not business users, then you will have to design a user interface specifically for Android and another user interface specifically for iOS. You can do both using FireMonkey, but they will be different forms, sharing the same business backend or same logic backend. And when you have a business application, that's less a case, because for business applications, there won't be like a million applications in the App Store doing similar things. There will be one that's specific for a business that needs to be usable, but not as polished as an end user application that's being used by millions of people at a time. So you need to be aware of that too. There are many other conferences about user experience. If you go into the mobile world, visit one of those conferences because it's very enlightening to be there. I know that a couple of more or less standard conferences that used to focus on one topic and now are merging in other topics. And that's one of the reasons that Jörn has his presentation later today about user experience, because it's getting more and more and more important. It's windy here. The cool thing with Delphi is that it's as soon as you have designed the application in the designer, you can run it and hand it out to your end users and have them experiment with it. And that's one of the things from the mobile world. Give your application to end users as soon as possible, even before it's completely finished. Have them start using it and give them feedback. The mobile world is moving very rapidly, even within businesses. So you need to shorten your development cycle. So start building it, give it the same day or the next day to a couple of users and ask them for comments, because that's the only way to shorten your development cycle and give feedback about usability. Because mobile devices are all about usability and much less about functionality, because they're so tiny, so they're limiting functionality. Here is a choice. It's basically the choice between native and not native. And it makes sense for applications that rely on user interfaces to put as much as the user interface work onto the GPU, the graphical processing unit. And FireMonkey does that, and most other development tools do that too. Usually, most mobile applications do not heavily rely on CPU processing power, because they often are tiny, don't do heavy calculations and such. Most mobile applications depend on the graphical power of the mobile devices and not on the CPU power of the mobile devices. Lots of applications, though, use a lot of storage, especially business applications. I've experienced with a couple of clients that use mobile devices, for instance, in their warehouse. And one of the things about mobile applications is that, well, like the hotel Wi-Fi, it's not reliable. So it means that you will probably not have a network connection when you expect the network connection to be available, which means that any business data that you need to cache on the device. And any updates that you want to send to the outside world, you will cache on the device as well. And as soon as a network connection is established, you will send out the updates to the rest of the world. And if you cannot send directly, then your application needs to have a mechanism to cache it locally. Which means that you need to be able to store data locally and access that stored data quickly. And that's an important part where Delphi plays a role, because it has support for interbase on mobile devices, SQLite on mobile devices, and potentially other databases on local devices as well. And those databases are native and run very fast. So that's one of the things that you need to be able to access data fast. So true native applications, yes, but those applications rely more on GPU than on CPU. In the business world, often you have quite some data that you want to cache locally, so you can take advantage of the local databases that Delphi supports. One of the main advantages of using Delphi for mobile work is that you can use existing code in your Delphi applications, which means that you need to think about how to separate the existing business code from your existing desktop applications and reuse that in the mobile world. And that's why I came up with this tiny tic-tac-toe example that shows how to organize your stuff. And this is cool, because Delphi, you have one language, one platform, one IDE, and if you do it in a smart way, you can reuse that stuff. How many of you people already have started reusing your code bases from Windows to something like a Mac or a mobile device? Okay, that's only very few. The key thing here is get organized and make sure you can cut between the user interface and your application logic. And there's number 5. I heard today, I forgot which news site it was, that in Ireland there has been a leak of about 1.5 million credit cards, including the 3-digit code on the back of the credit card, the verification code that the credit card company uses to verify the credit card. So all the information, credit card number, CV code, name, date of birth, etc., were leaked because the information wasn't stored at all where it should not have been stored, and the information was either easy to decrypt or not encrypted at all. And with so many devices communicating with each other, it's very important to think about security in advance. Being native on a platform makes it easier to cope with security because there's less layers between your application and the platform. But even if there's not many layers in between, you can do really stupid things. So when your data could be sensitive, and sensitive starts with login information that you use for communicating between your application and a business backend with the outside world. You need to store that in a secure place, and you need to make sure that other applications cannot touch that secure place. In a sense, mobile devices are a nightmare for that, because Android devices can be rooted, iOS devices can be jailbroken, so other applications can get in between. So security is even more important in the mobile world than on the desktop world. Of course, the desktop world, you have viruses, but you have very good antivirus software, so the risk of viruses is much less than on the risk of what a virus does is not as big, usually in a business environment. For an end user environment, the risk is really big because a lot of end users do not run antivirus software. So if you're, depending on where your applications run, if it's business applications, the risk is not that high, but on desktop for end users, the risk is high. And the same holds for the mobile world. You need to think about the risks and how to counter those risks. Interface on mobile allows you to store data in an encrypted, secure database. That's one of the things you might consider. The good thing about both iOS devices and Android devices is that they offer a clear barrier between applications. So when you have two applications, application A cannot see the data of application B, application B cannot see the data of application A. But that becomes a risk when the device is rooted or jailbroken, because then there can be applications on the root level or on the jailbroken level that can access any data, and then you need to secure any data you are storing. And that's when you need to look into things like cryptography, public-private key encryption, etc. Okay. DataSnap is one of the protocols that you could use for encryption. But even a simple thing like using HTTPS for communicating with backend server prevents a lot of security issues. Actually, has anybody watched the last couple of weeks the information about Snowden and the NSA and the Americans? Not only the Americans grabbing data. Anybody heard about the Yahoo and the Google stuff? Okay, this is how it went in the real world. You have the internet, and you have all those end users with tablets and smartphones that talk to Google. And Google has its own cloud and its data centers around the world. And I think about 2 or 3 years ago, what Google did is make this traffic all go through HTTPS, which is hard to tap into. So what the British did was use those links, dig them up from the ground, put an interception in between, and listened to all the traffic that was inside the Google network. So what Google now is going to do is using encrypted traffic, probably not HTTPS, but an internal security mechanism for the internal traffic between data centers. This is how security can matter, even for big companies where, well, nobody ever thought about, oh, they're going to dig up our private lines that are ours, and we assume they are secure. So assume everything is insecure and start from there thinking about, okay, what's the risk if this information leaks to the outside world? What's the risk of this information leaking to the outside world? Okay, time for some demos, especially about setting up your development environment. And this was in fact one of the things that picked me this morning. When I started Delphi, my connection to my Android device wasn't there. I thought, what the hell? And somehow some critical settings in my Delphi environment were just gone, and I'm not sure why. So I made a couple of slides showing how I restored it. And this happens, and this, luckily, I found out during the first session and not 5 minutes before this session. But bad things will happen, and that's the fun about a session like this. I can show you what can go wrong, so if it goes wrong in your situation, you can cope with it as well. Okay. Is this microphone working as well?
Yeah.
Okay, cool. Let me see if I have a connection now. Yeah. Better? Okay, cool, great. this was my old smartphone. And one of the things I've installed is a tool that shows you the CPU ID and if it has Delphi support at all. And the thing what to watch for is that for an Android device it must be Neon compatible. If it's not Neon compatible, Delphi applications will not work on it. The good thing is we're starting with ARM v7. All devices are Neon compatible. Well, at least I have not seen a device that's not Neon compatible that has ARM v7. And the devices that has ARM v6, which are devices usually about 2 years or older, about at least half of them has Neon compatibility. So it's a reasonable baseline for an Android application. But be prepared if you will have end users that have older devices that there is a chance that they don't have Neon and your Delphi applications will not work on it. There is this back button. Come on. Yeah, screen capturing is a bit slow. Marco was using an internal tool from Jim McKeith, the MVP manager at Embarcadero. He wrote that in Delphi. I'm using a different tool called RAD Screen, which is written in Java, so you need Java on your Windows machine as well. I like this. Well, they're different, and I like this tool because it shows you the devices and shows you how the device actually communicates to Windows and to Delphi and to RAD Screen. And that's using ADB. And ADB is a key thing in getting your Android stuff to work from within Delphi. It's the Android debugging binary, and it sits in between anything on your PC and your mobile device. And you can actually see it running inside Windows. And I'm going to show Process Manager, because Process Manager, let me find it. Process Manager actually shows you where ADB lives. And ADB, this text, is that large enough for the back? Or, no, okay. Let's do it this way. Still too large. Let's split it into a couple of things. Okay. This is where ADB lives. Well, this is where the ADB lives that Delphi installed for you when you install Delphi XT5. The not so nice thing is depending on what software you install on your Windows machine, there can be multiple ADB.exe machine versions, and they're different. So on my machine, I have at least 3 different versions of ADB, and it's a very clean virtual machine. There's not much software on it. One of the things I found out the hard way is that when you want to connect your device and you want to install the software with the USB drivers to connect it over USB, most of that software will install their own version of ADB and put that version into the Windows path and start that software when you log into Windows, so that version of ADB runs, which of course is incompatible with the version that Delphi uses, so you cannot connect to it. So the lesson I learned was try to install as little software for your particular device as possible to make the risk of the wrong ADB as small as possible. The cool thing about Droid at Screen is that it has a restart ADB, which just kills any ADB.exe running and then looks at the path that it knows about and starts that version of ADB. And this is why I like Droid at Screen a lot. Not only because it shows me a screen dump of what's going on my Android device, but it knows how to restart ADB. So what I've done is I've written a couple of batch files that allowed me to run Droid at Screen with the correct path for here it is. This is the thing. It calls this batch file first, and this batch file sets the home directory. Usually I have a much bigger screen. The not so cool thing about conferences is that they have beamers with 1024 by 768 and then move the beamer in front, so you have a big black portion on your screen which they can't blow up. I have a beamer at home that I think I bought it in 2007. That's about twice the resolution of this, and still they, well. Okay. So these batch files help a lot, and those batch files are part of my public repository. And I'll show you where they are if the internet connection works. This is my public repository, and this is my conferences repository. And I'll make sure that in my conferences repository, I already uploaded the ITDevCon stuff from yesterday, and I'll make sure that the batch files will be both in my standard repository and in my conferences repository. And in the recent activity, you will be able to see where they are. And if not, you can browse through it. Right now, there's only 2 years in it. I'm filling it. There's a backlog of all the other conferences I visited last year, and I think I did, yeah. No, I didn't put them here. They're on my main repository. I'll make sure that they end up in the conferences repository as well, so you can download them. They're really handy because the SDK and the NDK are the key parts of getting from Delphi to Android. So the SDK contains ADB, and the NDK contains the binary portions that Delphi uses to make a native application. So the NDK is for building native applications, and the SDK is for building Java-based applications. And that's what went wrong in Delphi this morning. This one. There's a whole video at the Embarcadero site that helps you get started with iOS and Android. But basically you need the SDK and the NDK. If it's not installed, then Delphi will install it by default on your hard drive unless you disable it. And these are the default directories where they go into. And when it breaks, then it will look like this in Delphi. And this is how my Delphi looked this morning. So when you go to Tools, Options, and then let's do this from Delphi, Tools, Options, and you go down in Environment Options to SDK Manager. This list was empty. So I had to add the information, and when you do add, you are allowed to select the platform, so select Android there, and then you have to enter the SDK base path and the NDK base path. And those are in the PowerPoint slide. Those are the default locations that Delphi uses. And if you have a different location, I know quite a few people that don't install Delphi in program files, etc., because they have organized their machine differently, then this is the place where you have to enter the SDK and NDK information. And when you do that, then Delphi will start looking inside the SDK and inside the NDK for all the tools that it needs. And one of the things that you will see is that it uses a key tool and a signing tool. And this is part of the Android platform security. When you deploy an application from anywhere to an Android device, it needs to be signed by a key indicating who is the developer of the application. And that's what these tools are for. So if you have done that and you plug in your Android device, then Delphi automatically will recognize that the device is connected, and under your project there's target platforms, and when you have an Android platform under your project there's a target node under it, and it automatically will select the device. If I disconnect it and connect another device, I never want to do this, but never is not an option here. Sometimes stuffing Windows is not really very logic. And on the device itself, you have to enable it for debugging. Let's go. And that depends, oops, that was the wrong button. Does it fit? No, I need to make it even smaller. Yeah, this fits. Come on. I want to go to settings. Let me see where it was. Ah, yeah, it's this is a Google Nexus 5. The other is a HTC Desire. No, it's an HTC Sensation. And it's slightly different for every device. On the Nexus 7, it's under developer options. So at the bottom here. Oh yeah, that's the thing. There's developer options there, and the first time you click it, it doesn't work. You need to click it 7 times in order to get it work. And if you've done it 7 times once, it'll remember that you did it 7 times. Is anybody old enough to remember The Hitchhiker's Guide to the Galaxy, the book? Okay. Anybody? 2 or 3 people? You're the real geeks here. It's a book by Douglas Adams. This book. And they don't have the back cover on it. This is the back side of the book. Don't panic. It's all bits and pieces software. Back in the 80s, they wrote a text-based adventure for it. And when you were somewhere in a spaceship and you knew there was something behind the door, you wanted to open that door, and you had to try like 3 or 4 times, and the adventurer would tell you, no, there's nothing interesting behind this door. No, there's nothing interesting behind this door. No, there's nothing. oh yeah, there is something interesting behind the door. The door would open and you would find a key that was very important in solving that adventure. Well, it's the same for the Android device. You have to tap it 7 times and then you get in and then you can debug. It works similarly for the other device. And what you can see is that Delphi, the target, automatically updates. The HTC Desire has it on a different place. Where was this? No. Settings. Crap. Settings. Oh, I forgot to. Yeah, that's the not so cool thing about this tool. It forgets the magnification factor. So let's do this again. I go to the home screen. Then I touch the settings button and choose settings. And then I scroll down to developer option. So here it's under developer option. And what you need to select is USB debugging. And what happens then is that Windows recognizes your device as having USB debugging capabilities and starts installing a USB driver for you. And this is the tricky part. The Google drivers are installed by default, and for other drivers you have to browse and see where you can find them. But there is something on the internet called Universal Naked Driver, which I have uploaded to my repository, which has the drivers, which are originally the Google drivers, but they have modified them to work with a much broader range of devices. Almost any popular device is in that list, except for devices made in China. So that's one of the drawbacks. When you have a specific device that's not on the public market, it's hard to get the right USB drivers for it. So when you have such a device, what you do is you develop on a more popular device that's more expensive, but similar to the device you're actually going to put your software on, and then later on in the project you put it on the device and run it there. So you cannot debug on this one, but you can run it. So you're looking for a similar device that there are drivers for. This is not only a drawback for Delphi development, this is basically a drawback for most of Android development. You need a USB driver to use it from Windows. I heard, but I have to check, that from when you connect the device to a Mac, that the Mac doesn't need a specific USB driver, and then you can use the ADB from the Mac to do the communication for you. I have seen that John McKeith, and the information about the drivers is in my PowerPoint slides. I have seen that Jim McKeith and a couple of Stack Overflow questions talk about how to connect Windows to a Mac, and the Mac has the connection to your Android device. Okay. I won't go into details about that. It's on my research list, and when I found out, I will publish a blog article on my blog about it. Let's go back to Delphi, because now I have a target and can run the application on it, just to show that it actually runs. And in the meantime, I'm going to applications on my Mac and start another piece of software which is the RAD PA server. And the RAD PA server sits in between your Mac and Delphi in order to run your macOS software and your iOS emulator software from within Delphi. So let's start that one as well. Use a password test. So we can start running it from Delphi as well inside the iOS emulator. The PA server is also part of Delphi. So this is the directory where Delphi copies the PA server installation software. You use the PA software to do remote debugging from Delphi to a Windows system, and that's where you need to set up PA server.exe, and it's used from Delphi to remote debug on a Mac, and that's where the RAD PA server exe5.package comes from. And you install this on your Mac, and then you can run the PA server on your Mac. Okay, and by now. And this always takes a little bit of time running on Android, because it needs to copy the installation of your application to your Android device, perform the installation of your Android device, and start the debugger on your Android device. And this can take anywhere between like 10 and about 40-45 seconds, depending on how large your application is and how fast your USB connection is. Okay. And what we see now is that it actually runs on my iOS device. I can, for instance, click on computer plays 0 and click on computer plays X and start a game with X and see how the computer will play against the computer. And it's a real simple algorithm. It can lose. But when playing against itself, it's playing against the same stupid algorithm, so nobody will win all the time. But it's just to show that you can have an algorithm different from the user interface. And I can do the same on a Mac. So I can switch my target to the simulator. And for that, I need to have a target, which is the iPhone, and I have to have a profile which tells me where my Mac is. And that uses the IP address of your Mac. So depending if your Mac is on an external network, that will be external IP address. And this time my Mac is on an internal network because I use Windows as a virtual machine, and there's a virtual network between the virtual machine and the Mac, which uses this address. So let's put test as a password here, and then perform test connection. Ah, crap. It hates me. This is not the internal network of the Mac. Let me see. 16. It's either one of those. I presume it's this one. Okay, it's this one. So in order to do all this, you need to know a little bit on how your network is organized and who is which connection. And that's actually why I'm showing this demo, because it's nice when demos start working from the first time on, but it's much nicer to see what can go wrong and how to fix what goes wrong. Okay, so I have the PA server in place, I have my network connected. So now I can start the application on the iOS simulator. And what now happens is that automatically the desktop switches to iOS, starts the simulator, and runs the application. I broke something in my Delphi, and I'm not sure what yet, because 3 weeks ago I could debug on the iOS emulator. Right now I can't, so I'm talking with the guys in Scotts Valley to see what I screwed up and how to fix it. But it now works on iOS as well. So we have about 5 minutes to show you how I organized this application so it works on all these environments. And it's what I said earlier in this presentation. It's about preparation and thinking ahead on what you want to do. Okay, let's quit the emulator. So Delphi knows that my application has stopped, and look at the source code of the application, and this is, I wish I had more screen space. This is the mobile project, and this is the VCL project, and what you see is the organization is very similar. You have a directory 1 deep and 3 deep, and you have a couple of things in your project directory itself. And basically, that's the form unit and something like a controller. And even the controller for FireMonkey is centralized, because the controller for FireMonkey is shared between macOS, iOS, and Android. VCL runs only on Windows, so VCL is only inside the VCL application. And for the rest, everything is shared. So I have library, I have the logic, and you see all those files are the same. So intermediate between them is the controller. And this is similar to my MVVM talk, but now done manually. So there's no binding, etc. This is very, very simple. What I've done, I have created a specific controller that knows what kind of user interface stuff needs to be bound to the underlying logic. And what I've done is I have created methods for all the stuff that can be called from the user interface. This is very similar to the MVVM talk I gave yesterday, and very similar to the MVC talk that Daniele gave yesterday. It's all about having a third thing in the middle between your user interface and your actual logic. This is the binding, and this is explicit binding. And it descends from a generic abstract UI controller. So this is the specific implementation for VCL that knows that when you have a checkbox and you want to set the state on or off, it knows that you have a checked property. It knows that when you want to set the text for a button, that you need to have a caption. It knows that when you want to show a message, that it's in the VCL.dialogues unit, and it's a method called showMessage. Let's go to, oops. Oh, crap. It works. This is the other unit I wanted to, no. Yeah. This is the one I wanted to show. The abstract controller has the actual business logic in it. So it knows how to get the buttons. So this is the intermediate between abstract user interface and the logic. It knows about the buttons on the screen. It knows about the checkboxes or the on-off controls on the screen. It knows about the start buttons. It knows about status text. It knows about how to show messages. And it has a big create constructor where you pass in all the stuff from the user interface. And this one has methods like create a player, which we need because a player knows about how to move to a square and play on that square. It knows about the buttons, it knows about how to play, and if something goes wrong, then it should show an exception. It knows how to transform from one of the 9 squares into a board button. It knows how to clear the board. It needs to go to the game, clear the board, and then copy the board to the view. So this is all. This is basically the abstract thing that knows about the user interface and how to map that to the actual business logic. And behind the business logic, there is a game and a board, and there is pieces on the board that can be either clear or an X or an O. So the business logic, the actual business game logic, is inside this directory. And in a mobile project, you have the form, and you have methods on the form, and you have the controller. And the controller is similar to the VCL controller. In the VCL, you had a check property for a checkbox. In FireMonkey, it's called isChecked. In VCL, you had enabled on the button. Luckily, in FireMonkey, that's also called enabled, but it's a different button class. So that's why you need to have it in this controller. And in VCL, on a button, you had a caption to set the text. In FireMonkey, it's called text. So this very thin intermediate layer allows you to switch between VCL and FireMonkey. And the only thing that's left in the form is the position of the actual controls and very simple events. All the events, or all the event methods, will route the events to the controller. The create will create the controller, the destroy will remove the controller, and there's a timer that allows the game loop to continue, which tells the controller that the game loop ticks, and the game loop can decide, should the computer move or should I invite the user to move, etc. And you can do similar things for business applications. You need to abstract your logic into a central directory and make sure that central directory does not depend on FireMonkey or VCL. Then you need to write a small layer in between that allows the view logic to communicate with the business. And from that view, you create descendants that's specific for FireMonkey or VCL. And getting this from VCL to FireMonkey and then to iOS and Android took me less than a day. And the reason was that even on the VCL side, when I didn't have the controller, I already had the subdirectories for my business logic separated. So on the VCL application, I didn't have the controller. I had all the logic in the VCL form, but I did have everything for the game in a specific directory that was not dependent on the VCL. And I've had this for years because this is a demo that started in Turbo Pascal 6 with a DLL that you could call from Visual Basic for DOS 1, and then from Visual Basic .Windows version 1, and then from Turbo Pascal for Windows, and then I wrote a version for Visual Studio, so you could use it for C#. So this code, this business code has been sitting in a directory on its own for years. And because it was already separate, it's very easy to move from one user interface into another user interface. It's just thinking about the layers in between. So, apart from the the introduction about what kind of mistakes you can make when designing user interfaces. It's getting your technical infrastructure into place. So I have slides for that. I have not shown all slides. I made them so that if you start developing iOS applications, you can have the iOS slides. So I'll make sure those slides get updated as well. I've shown the slides for Android because that's the thing that's really new in Delphi. I will make sure that all the slides from Pavel Glowacki, including the mistakes you can make, will be online. And I've made a few slides about the tic-tac-toe application, because the tic-tac-toe application, including the FireMonkey support for macOS and Android, is already on my public repository, so you can download it there. And there will be a link from the conference to the public repository, so it's easy to find. And I will make sure that she gets everything on a USB stick so that you guys get the stuff afterwards as well. So if you want it fast, go to the public repository. If you need it slower, wait for the conference organization to get it to you. Time for questions. Okay. Really, no questions? Was this session so bad? Oh, sorry for that. Okay, thank you for listening to me, and enjoy the rest of the day.
Can you try?
Yeah. Okay. Can you hear me, everyone? No one can hear me. That's okay. That's comforting. That will be a good start. Okay. So welcome to this session with this special name. Don't be that. We made that software. You can fill in whatever you want on these characters. The topic of this session is user experience. That's what we're talking about. And we'll walk you through a couple of examples and guidelines which will make you design better software. We'll go through a little method you can use to ensure that your user experience is maintained in the software you use. Okay, a little bit about me. My name is Jörn. It's obvious that I was born before the internet age because it's not an international name, but it's pronounced Jörn, straightforward. I have 4 kids, and I try to raise them well, as you can see. They're well educated.
It's all Marco book.
Yeah, all Marco books. He's not here now. So the reading, the last one, Pascal Essentials. And I have all the books. Okay, I'm the owner of the software company called Optimale Systemer. That's Optimal Software Solutions. We're located in Norway, and we do various stuff. User experience, we have a usability lab with eye tracker features, we have an open device lab, but most of the days we are programming in Delphi, so we are faced with all the developer challenges every day. We have a table out in the hallway where we demonstrate Smart Mobile Studio, which is the product we have for international market. That's a product where you code in Object Pascal and you compile it to HTML5 and JavaScript. And you can run it on all web browsers platforms, on your mobile device, on your desktop. We'll also have version 2.0 is about to be released, and in that edition we will also be able to program microcontrollers. And Christian Bødde, he's holding a session about that right afterwards, so you should attend that. It's pretty cool. We have lightnings and motors and joysticks and everything. Okay. So, why is user experience important? Well, every day when I walk around, I peek on different solutions and peek on users and see how they experience their software. And I always encounter that they have problems with the software they use. There are not always big things, but there can be small things, small annoyances that makes it difficult to use the software. It's like that. When you do an education, the definition of an education, that's what's left when you have forgotten everything you learned. That's a nice definition of education, right? But what it means is that you sit with a couple of glasses, and that's the education you have, that's how you look at the world, that's how you see the world. So I know the dentist. When I go to the dentist, I look like this, okay? And I know what's on the mind of the dentist. It's not the software he's using, it's not anything. What he's thinking of when he looks at me and in my mouth, he thinks, hey, I think I can afford my Porsche soon. That's what he thinks of. Doctors, they can look you in the eyes and tell you have some strange disease. And when you realize it's just fever, you can shovel something up your ear, and you'll be healthy in a minute. Police officers, what do they think about? I'm pretty sure they go around all day and think you have the right to remain silent. They're from Norway, these guys. Okay, but I'm educated as a software engineer, that's me. That's how I look, that's my everyday job. We're working with our software, and we're sitting in our comfort zone, and we have the glasses on where we think software, everything. My education is also in the user experience, so I always look at the user, try to imagine how is the user thinking of the software, what's the user, how does the user interpret the software. And everywhere I look, if I go to the grocery store, the cashier lady actually has to confront 4 or 5 different systems, and they're not always in sync. They have one system for the paying terminal, they have another system for the gambling terminal, a third system for the packages and the post office. So they need to confront several systems. And they are never in sync. They have never been organized well. And I'm pretty sure that the developers behind all these systems, they would pretty soon see how little this could be changed to meet the problems they're facing every day. The same in warehouses. There is an example, and these are new examples, just a couple of years old. We usually think of such problems as agent problems. But in the warehouses, there are examples of a person who has to front two different systems every single day. And the one system, Control O, that will create a new order. In the other system, Control O will close the application without asking if you want to save it. And that's a big problem. It's not a huge thing, and it's very easy to fix, but this causes lots of trouble. And I see these people every day. They think, who the hell made this system? Why couldn't they just figure it out? It's so easy to see what we should have done. It's also, I thought also all these worst case scenarios were also pretty old. But just a couple of years ago in Sweden, there was a man with cancer. He didn't recognize his cancer until a year later. And that's pretty serious. So he walked with cancer for a whole year without knowing it, just because of a user experience error. And in gas stations, school, even in bars, if you go in a bar and ask them to drink, to mix a drink which is not on the chart, they will say, sorry, I can't do it. It's not in the system. I can't create it. The stock will be all wrong. So this is what they face every day. Okay. So, what's the most important element in user experience? What's the one thing we need to focus on? Well, it's the user, okay? The user, that's the first priority when it comes to user experience. You need to know your user. You need to know a little bit about who is using your software. And you're not talking about the management, you're not talking about the people who pay for it, we're talking about the people who sit down and use the software every day. And from time to time, I actually see people advertise, hey, we have just released a new website and the management is really happy. And that's all wrong focus. Yeah, the management can be happy, but the user needs to know how this works. So, we have a little problem here, because this guy is going to figure out who the user is. And he has his comfort zone. He likes sitting in the basement. He likes to sit there, and he is not very comfortable with confronting all the external stuff. So this guy is actually trying to figure out what all these guys think. And it's absolutely essential that he do, because if he doesn't know who the user is, he will create a very strange system. He will not meet what the user thinks. He will not meet what the user needs. A very common way to create an image of the user and for the developer to be able to think like a user, it's to create a persona. A persona, that's a virtual user. So you collect various information about users and the user group, and you create a virtual user about the persona. It could look something like this. This is Jenny, 29 years old, single mother, Jack and Ellie. When she goes shopping as a family, she's always at an adventure. Ellie is curious about everything and often wanders off in a world on her own, unaware of her mother is. And Jack and Ellie, the kids, longs to run off and often try to escape from her hug. Two active children, a buggy, a bags, and a shopping to make for easy. And it's really, just by reading through this user case and this persona, you get a whole other image about who the user is. Okay, this is very different from the dentist we saw and the doctor we saw. If we see this description and think of this description while we're creating software, we will definitely create a software that's more suitable for this kind of user. So that's pretty important. Over the last few years, personas has been a bit criticized because personas, they can be a little bit too distant, so you don't get this personal feeling. And what you can do is what they call adapt a user. And what that means is that you actually go out of your comfort zone, you go out of your basement, your office, and you find a user, an actual user who fits your user group, and you get to know this user. You can interview it and have one common user for the whole of the team, or you can actually tell each team member to find different users. And each team member will have to follow that user and be the advocate of that user in all design decisions. So when we're throwing up a mock-up or throwing off a screen interface or whatever, you have to take care of your user. So if you're taking care of, and if you're managing a boy, 16 years old, you have to really think about what's important for this user, and you have to advocate it when you go through the design meetings. So that's a very nice way to do it, but it's not easy to get developers out of their comfort zone now to meet people. So you just have to decide it, and you just have to make some rules around it. But it's a very valuable method to know the user. Okay. There's one more thing. The user, it's definitely important, and perhaps just as important, it's the task. Okay, so the user, they're solving a task. No one is using the software just for the case of the software. No one is using the software because it's cool. When we create software, we think, this will be nice. He will use it, and this will be fun. We think that's the interaction point with the user, our software, but that's not it. They want to look beyond the user interface. They want to look beyond the software you have created, because they have a certain task to solve. So when they sit down in front of their computer, take for instance the dentist, he doesn't want to interact with the software. That's not the main task of the dentist. The dentist has tooth to fix, and he has to create some orders, and etc., etc. So that's what the dentist wants to do. The dentist, he wants to do his job, and he just uses the software as a tool to accomplish that task. It's a very nice exercise to try to think, okay, what's the purpose of my software? What's the task the user really is trying to solve? And if you can manage to write the purpose of your software in one sentence, you probably have a very clear idea about what the task is. But one sentence, it's difficult. In one single sentence, you should write down the task of the software and the purpose of the software, and you should be able to clarify in one sentence what the user will do. Okay, so the definition of user experience. There are several definitions of user experience. You have some definitions who say user experience, usability, that's software which the user continues to use. And that's a good experience, because if they have a choice, they can choose not to use it. But very often they don't have a choice. They have to use the software because there are no other options. Or perhaps the boss told them you have to use this software. So in that sense, the definition is not good enough. The common ISO definition of user experience is that user experience encompasses all aspects of the end user interaction with the company, its services, and its products. So user experience, the definition and the term, it has evolved over the last years. Previously it was more about human factors, how the angle were on the chair, how you were sitting, how the lighting condition were, etc., etc. Then it moved on to be more about the usability, how fast is the product, can you solve every task on the product, and very product-oriented. Over the last few years, it's user experience, it's the overall experience. So everything, every interaction the user has with your company, the services or the product, it's related by the user experience definition. So when you send an invoice to your customer, that's part of the user experience. When the user calls your hotline support, that's a part of the user experience. When the user wants to chat via support via mail, that's an interaction, and that's part of the user experience. And the newsletter you send, so everything, it's about the overall experience of the user. So in essence, for the product part, which we'll cover today, it is to remove all doubts. Okay, in the product, when you create software, you need to have a clear interface, and you need to have a software where there's no doubt about what the user can do and what he should do next. In short, the system should behave exactly as the user expects it to behave. And that's important. At the end of the day, the main goal of user experience is to create a product where the user always knows what to do, and the user gets what the expected results of what to do. And it's also important that the software has a clear definition about the state. Okay, the software is always in a certain state. If it's waiting for a download, if it's waiting for something, you have to be clear about the state, which state the software is in. So these are the essence. Okay, so what can we do then to create a good software? Which techniques and which methods can we use to ensure that the software is good? Well, first of all, I have a couple of things I want to cover in this section. First of all, you have something called visual hierarchy. And visual hierarchy is all about elements in the screen that grabs your attention. If you look at this one, you probably all are looking at the same stuff. The biggest your eyes are here, it's catching the attention immediately. Then here, and then you have some small text down here, which probably no one is looking at. So this is part of visual hierarchy. So user will look at, first scan the page, and the biggest element and the most common elements, that's what the user sees first. Then he will do a finer scan to look over the elements with less visual weight. And finally he will read through the labels, etc. So this is how the visual scanning do, and that's in the human nature, that's just the way it works. We have a difference here, an example. This is with no visual hierarchy. Well, there is one element, it's the white space. The white space between the blocks. This creates a visual hierarchy. You could shove them all together and have a plain solution, but you have the white space, it creates some visual hierarchy. On this part, you have more elements. You have different colors, you have different sizes, you have different weights, and different shapes, and all of this will make a visual hierarchy. Yet another example. So we have some strong visual guidelines, which makes it easy to process, and you have some very simple things that makes the user look at various stuff. This is ITDevCon homepage. These also have various weight elements. So you will see different stuff on this page, and you have different weighting. And the biggest stuff is what you see first, the live view and the list over here. And the lesser parts will get attention later on. So when you create stuff like this, you can actually manage to lead the user's attention to different elements of the screen, just by designing and just by sizing various stuff. This is another example of mobile. Mobile is extremely important to keep the information load pretty low. We don't want lots of things to do, and it's impossible for the user, at least if he's on the run, to look at different and too much information. So you can use some visual elements to create them bigger and to create them in a different color and different shape, and they will grab the attention, and that's what the user will see when he looks at these screens. So that's important. That's one really important part of designing the interfaces. Be aware of the visual hierarchy and be aware of the visual components. Okay, so by using this visual hierarchy, you can actually create a visual flow. The elements which grabs the attention most will you look at first. And you will combine this with the tradition, at least in the Western country, that you read from top left down to the bottom right. So you will have this natural scanning from left to right, from top to bottom. And you combine this with the visual weight of every element on the screen, and you will see on this screen, for instance, you will create a visual flow like that. This is different. It's not a one standard, and when you come to visual flows, it will differ between user between users. You can use, for instance, eye tracking technology to scan 50 or 100 people and see what's most common. But in general, if you have the visual weight in your backend, you'll definitely be able to think about some of the visual flow in the solution. Here's another example. So by designing the page, you also create a visual flow, and that's really important to keep in mind when you design the software, because the user, they have something else in mind. They don't have the visual flow in mind. They don't look at the screen just to see the visuals. What they do, they're trying to do something. As we talked about a minute ago, the user has a task he wants to solve. And when he wants to solve a task, he has a certain workflow in his mind. And he knows, I have to do this first, then I'll do this, and then I'll do that. And if the visual flow doesn't match the workflow of the user, you will get some strange errors, because they will come into trouble, because they won't be able to find what they expect to find at the different sites. So it's important. Keep in mind that the user has a workflow, and he wants to do first this, then that, and finally this. And we need to create a visual flow by using visual hierarchy to create this flow in the visual elements as well. So you can do some sketching. That's a nice way to design solutions like that. When you do sketching with pencil and paper, you can create some solutions, and you will see immediately the visual balance in the solutions. This is one example, and you will see, by creating this, you will see immediately where the visual flow is and which elements will grab the attention the most on this. And the response by most users is that, hey, I'm a developer, I don't know how to sketch. Yeah, and I can understand. I think there's a page, I didn't find it for this session, I think there's a page which is dedicated to developers' drawings. And it's really ugly. There's nothing good on this page, and it's impossible to understand any of the paintings, any of the drawings. They have tried to draw a line, and they have tried to draw different stuff, but it's really hopeless. And I draw the same way. I can really not draw at all. But there is a solution, there is a rescue out there, and that's called UI stencils. Have any of you heard of UI stencils before? No, then the rescue is here. Because UI stencils, you can just order stuff like this, and you get these little squares you can draw inside. And they have different stencils for Android, and for iOS, and for Windows, and for everything. So you can buy different stencils, and you're safe, you're there safe. They also have papers where you can mock up a screen very easy and very fast, and it's very nice to use this. Okay, we have talked about the visual appearance of the software. We have talked about how the software and how the screen looks to the user and what the user thinks when he sees it. But he will also interact with the screen. He will not just interpret the layout of the screen. And one of the most important issues when it comes to action, it's affordance and mapping. Affordance and mapping, let's take affordance first. It can be a bit difficult to understand, but affordance is all about how objects appear. Okay, so every object, even if it's physical objects or digital objects, every object, they have an appearance. And that appearance tells the world something about how it's possible to use that object. For example, a door handle. It's pretty obvious that it's possible to grab the handle. Okay, it's impossible to grab it, and it's possible to pull it. That's the visual. That's the affordance of a node like that. So the affordance, it's really important. A button, the same thing. It's really, really obvious that this button, it is possible to push the button. Okay? It's no doubt at all. It has this visual appearance, and it has the affordance, and that says push me. It's possible to push me. These are the buttons from the elevators here at the hotel. And I push these immediately because they have the affordance. Hey, push me. It's possible to push me, but it's not possible to push me. The coffee machine in the hallway, the same thing. I'm pretty sure everyone pushed the button on the right or on the left, the big button on the side, because it looks like it's possible to push them, but to push the smaller button inside. So affordance, how you lay out and how you design your components, it's really important about how the user will, what the user think it's possible to do. And that's why I think it's very strange. Why did Apple go for the flat design? It's absolutely no affordance in this layout. What is it possible to push on in this one? You have, okay, you can think that it's possible to push on this, of course, but what about cancel, password, and done? What's the difference between them? They look all the same. And it's possible to push cancel and done, but not password. So I think this is a pretty hopeless when it comes to affordance. It's pretty hopeless to understand what it's all about. Yeah, same thing here. Fabrizio,
Yeah.
on ITDevCon, how can I find a hotel? Have anyone went through this page to find a hotel? Which element is it possible to push on this side? Anyone knows it? Fabrizio, do you know?
On the map. I will push on the map.
On the mark, yeah, that's a
On the
good
map.
suggestion. It's really a high affordance on Google Maps. But what you need to push on this page to get to the hotel is this line. That's the link to the hotel. And it is absolutely hopeless to understand it. You have to draw your mouse up and down to find it. And even worse, I'm criticizing a bit now, but you can handle it. This one is not possible to push, and they are exactly the same. Okay, consistency, really important. Things that looks the same, people expect it to behave the same. And they expect it to be possible to push things that look like buttons or links. Links is a learned affordance. When you see something with a blue line under, we think it is possible to click on it. Okay, the other thing we talked about next to affordance was mapping. So when it comes to mapping, this is all about having the control on one side and what you're trying to control on the other side. And it should be a very natural mapping between those things. If any of you do cooking, you'll always face this problem that you have 4 plates and you have 4 buttons. But there's not a good mapping between these nodes and these plates. This one is a better mapping because you have a system from left to right and you have the nodes from left to right. So it's easy to understand that this one is linked to this one is linked to this one. So that's all about mapping. It's a relationship between the control and what it's trying to control. And when you design software, you should think about these two. Group the things together that belongs together and make sure that the control layer, they control the things you have in the same area. Okay, talking a bit more about perception, how the user sees stuff, because this is really important. This is one of the main things that causes trouble for users. And this is on the basic level. This is how our psychology works. This is how our visual system works, and this is how we interpret stuff when we see it. The Gestalt principles. Have anyone of you heard of it before? Yeah, you should have heard of it because it's a very common thing. And Gestalt, hundreds of years ago, they did several tests to figure out what's going on and how the human brain intercepts various stuff. And they found out pretty obvious things actually, but at the same time pretty amazing. But things that stands out. We like to organize stuff. Things that stands out, even if it's color, the position, or the orientation, or the shape even, it will stand out and it will look different. So when we look at this, we expect all of these to act the same way, and this one to expect another way, to behave another way. That's how things work. We connect things together by size. So if something has the similar size, we automatically think that they are related. The same with texture. There's another Gestalt principle here. In grouping, things that belong together, stand together, close together, with white space between, we think that they are connected together. So in this side we have these 4 groups at the top, and we have 2 main groups at the above and below. Shape the same thing. So when we create stuff and we have buttons or edits fields or anything, we need them to look the same and behave the same. This is the grouping. And then when we create interfaces and we line up a bunch of groups, you always bunch of actions. We always have a lot of buttons we want to do some actions with. And all of these should be groups. The buttons with the same effects, they should be grouped together. Closure, same thing, also a Gestalt principle. We close the lines between every open white space, and we create a square and a circle based on what we see. Okay. So, we have this user model. It's related to what we talked about before. The user, he has a tasks he wants to do, and it's the user's model we're concerned about. The developer might have his model of how things work, but the user, he has another model. And when we sit and create software, we always create the model as we move along. Okay, so we will always create, and we will always think, okay, this is obvious because this is related to an underlying architecture, and we will understand it immediately. When a guy and a user come and use the interface and the software, he will create another model. He will create another model about what's linked together. It's just like driving a car. We see the wheel and we see the pedals, and we immediately think, if you push this one, it will make the car go forward. But you don't reflect about what happens under the hood. So this is what the user models are. So what we need to do as designers and developers, we need to understand what the model, the user model. We need to understand how the user thinks, and we need to create a solution similar to what the user model is, so we map the user model. Okay. Toggle buttons, that's always a big problem, because if you have buttons which both contains a state and they contains an action, the question is, what should the label say on a toggle button? Should it describe the state of the actual state, or should it describe what will do if you push the button? This is again from iOS, and the question is, HDR photography, is it on or is it off? How can I turn it on? How can I turn it off? Will it be turned on if I push the off button? Is that the state or is it the action? It's a bit clearer if you see the actual difference, because now it's more obvious that it's on, because you have this difference between this color here and the color around. But on this image, it's really impossible to know if it's on or if it's off. It's really impossible to know how should I turn it on, because you have to look for the off button. Instead, you should use flip-flop buttons or something similar that's a very clear state. You have something either on or off, and it's very easy to see what state the button is on. There are some difficulties here as well, but not in this one. But you can have flip-flops with the captions that makes it difficult to understand them as well. Okay. So the question is, we have looked at some things you can do with your software to create a good software, and we have looked at some principles it is possible to apply to the software to make sure that it's easy to understand. And the question is, how can we ensure that all this actually works? How can we verify that the software is okay? When it comes to usability engineering, there are things you can do in every stage of the life cycle. From before you start implementation, you can start user research, and you can start user testing, you can test mock-ups, you can test layout and wireframes. So you can do things in every step. You don't need to wait to have a prototype or to have a final product, but you can start immediately. But it's important to keep it simple. To have this applied in any office, it's very important to keep it simple. And the simplest stuff actually works. It's some very, very simple things you can do to try. This, Steve Krug, he has written a couple of very good books. This is the guy behind the book Don't Make Me Think. And it's a very good book recommended. That's about web design, how you could create web pages in a good way. This book, Rocket Surgery Made Easy, this is all about how you can do stuff the easy way to the user testing, how you can create a positive atmosphere in the office and in the company, and have this as a tradition, a good tradition. And this is what we're trying to do. This is the essence. We invite a user to test the software, very informal and very lightweight, not a big thing, and he will tell you what to do. And here's the developer thinking, I'll be damned, didn't think of that. So the user, they will always do different stuff with your software. It can be a bit of a pain to look at because they don't do what you expect them to do. So we need to keep your hands off and let the user do whatever he wanted to do, and you have to learn from it. And that can be hard to see people abuse your software. If you can afford to hire a usability professional, then do it, because they have lots of experience they can apply to what you are asking. So if you can afford it, hire a usability professional who can help you. But you will also come a very long way by applying some simple stuff yourself. And these are the steps you should do. This is the essence of the book, actually. This is the essence of Rocket Surgery Made Easy. So what you do, you recruit loosely. What that means is that you don't pay particular attention to the user group. You are not very strict about finding exactly the user you need. You can take someone delivering the mail, or you can take someone, take anyone, take your grandmother or take your aunt. Get someone to use your software and invite them to an informal meeting, an informal test session, and you put off one morning every month, okay? Set up a first Monday every month, for instance. That will be the usability day in the company, and that's when we will do the testings. And you invite 3 or 4 users to that day, and you'll do some very simple tasks with the user. Make it a sport, make it something, make it an event more users want to apply to, attend to. Make it a sport, make it a thing, an event people would like to come to. Bring some fruit, bring some cake, bring some coffee, make it a good thing. Set up a simple test room, a place where you can have the user and the moderator alone in a room, and set up a simple web sharing or screen sharing solution, so the attendants, the watchers, they can sit in another room and follow the session without interrupting. It's not very much you need to do as an attendant or as a moderator to interrupt the user. The user is very aware of everything happens. So it's very good to have them in a separate room and have only the user, the test user, and the moderator in the same room. And invite people, make this a good happening. And then you have to decide a few simple things you should test in each session. Write a few task scenarios up front. Think about the scenarios you have. Write a few scenarios and have them on paper so you can present them to the user during the session. Okay? Have a checklist. Even though it's boring, you often forget stuff when you're on the days like this. So have a checklist about things you are going to say, things you want to test, and things you want to find out. That's the purpose of the usability test and the informal usability test like this. It's to find out something, it's to test something, it's to verify that something works or what could be improved. So what you do, you invite this user one by one. You put on approximately an hour on each user, and you put off a 5 or 10 minute introduction. You put off half an hour with the actual testing, where you go through some test, for instance, order a hotel, write a report, create a new order, have some tests and some tasks the user should do. And between the sessions, you go to the guys who have been watching the session. They have had some tasks as well to write down things they have seen and things they have observed, and usability areas which can be improved. And then you do a debriefing between every session, and you write down a few things you need. This we have to fix for before the next session. And then you actually improve it, and you have 1 month to improve those usability issues before the next release. And in the overall sense, you will actually improve the software very, very well on this. And this works very good. It's not too much effort you need to put into this. You put off 1 day every month, and you do some testing. You are a bit concentrated on that single day. You do what you need to do, and you're having a debriefing, and everyone on the team agrees on what they should do before the next release. And this won't just be a backlog situation where you put things away and it will never be fixed, but it will actually be fixed before the next session. So this is a very good way to actually improve the usability and validate usability. It could be perfect, of course, and that's just fine because you have verified it and you have tested that it actually works. But at the end of the day, when you try to test things, when you try to take your software and write a few tasks, you see that you actually have a very complex task. There are several things you want to test, and you won't be able to test them all at once. So we need this continuity. Okay, so I have misplanned my presentation a bit, I see now, because I don't have anything more on the agenda. But I think if there are any questions, we could take them right away. Anyone who wants to ask anything about usability or user experience. I could also mention that there is a very good place. This is the guys behind Stack Overflow. You all know Stack Overflow, don't you? Yeah, it's a very nice page with the questions and answers. And on this page you can ask programming questions and you can get answers. Stack Overflow has turned out to be a bit of a rude place, so newcomers are not, they get dissed a bit over there. But at ux.stack-exchange, only nice people attend, so you can ask questions. It looks like this. And you have one question, and you can ask your questions if there's anything you want to know more about. And the guys will give you some examples and refer to research and refer to best practices, and you can get some good feedback on this. Okay. If there's not any question, we have an early lunch. So, okay, thank you.
Hello. Okay.
Good afternoon, everybody.
Non funziona?
Still people coming in?
Sorry, you need to turn on the microphone.
Oh yeah. Now?
No?
No.
Need to be green.
Yeah, now.
Okay, good.
Good afternoon, everybody. I try not to shout. I think this is a very special moment. For many reasons, I'm going to reveal some things we are going to do in the future. And especially this afternoon, we will talk about the leap motion. And first of all, I have a very small story to tell you about Holland. Since you're most of all Italians, you've probably never heard of St. Nicholas. Have you? Nobody?
St. Nicholas.
Yeah? That's a guy that looks like the guy from America.
Yeah, Santa
And
Claus.
the only difference is in Holland he's earlier. He has a little helper, maybe sometimes more than one. And they're called Black Pete.
Oh.
And Black Pete is now becoming a subject in Holland's political area, because there are some black people that is like that. Now I found a solution for that, and I will show you how that works. We simply eat Black Pete. Could you? It's just a little chocolate, and I wanted you to have this because Jeroen Pluimers in last year gave everybody this stroke waffles, you probably remember. And I think it's a good habit to find each year something new like that. While presenting, first of all, I want to tell something about the leap. Needs to be reactivated. Still there. You can see my hands. Just to explain something, this very little thing does it all. It contains up to, I think, 2 cameras. I saw 3 points. I'm not sure what is inside of it, but it's an infrared camera, so it's not taking pictures, it's sending signals. It's a very small item, and it's meant to be just handled by your hands, so you can't act with your whole body, etc. You can, of course, but it won't show that. Now you must see that you have 10 fingers, and 10 fingers means it needs to recognize all those 10 fingers through space. If you go closer to it, they become bigger, and if you go further away, they become smaller. That's the 3D effect. Now, you must imagine what that means. It's up to 60 frames per second that are encoded. So you need a lot of memory on your machine. You can't do that on a very old machine because it simply doesn't work properly. Maybe not at all. So if you have Windows 7 with something like, let's say, 4 gig of memory, doesn't work, or not properly. It needs a lot of memory. We will try to make it available under the MacOS as well. That will be in December, I think, when it will be done like we developed it now. Just last Monday, I was able to receive the latest version of this link. And we now managed to make it precise enough so you really can handle something. I'll go back to my presentation. Well, you've seen the object, of course. It's comparable to a memory size. Don't know the name. Anyway, there is a point as well, so you have an impression of what the size will be.
The microphone.
Sorry?
The other microphone, you can use the other one.
Okay. Oh, like that. Yeah, that's better. If you use this information, it is first of all necessary to find out which fingers are available, because you immediately start like you are handling something. You want to act, to grab something, etc. What we did is different. We made it not easier, but simpler, because we want to push a button, and because we,
Okay.
thank you. Because we, using one finger for a button, you can push with your full fist, of course, but I don't think that really works. You can imagine that instead of 10 fingers, now you have to find out which will be the finger that you're using for this leap. I mean, the leap says, sees 10, so he's giving you the information of 10 fingers. And of course you have to correct that to make it available. First of all, you point by hand, of course, and then there is one finger. But the leap still sees your hand. So there has been done some work to deduct what it is. If you point at something, you will have to see where you're pointing. And our first mistake was when we started this project, simply how to find out where am I pointing. And the first thing we did is make a fingerprint as a little mouse cursor, so you can see where you are with your finger. And of course you can do that for 10 fingers, etc. That's all for you to discover. So the parts of this are written in the magazine as an article which explains it extensively, but it should be updated already, so in the next issue there will be new information about the latest version, because we're developing simply every day. And we have to correct some things because it's becoming more and more precise since we started. I can show you the first version and you'll be surprised how bad it was, but still working. Here you see what I just showed, etc. The fingers moving around, etc., which is nice, but well, what can you do with it? First of all, there is a piece of coding that tells you how much fingers are available, and it will there's the fingerprint. It looks very large, but it isn't. It's very small in fact. And I made a little red point in it so you can see it easily. It might even become a little smaller. Now this device is already working with coder for Pascal, which means Delphi and Lazarus APC if you want to, and it's available in coding for both series. So if you download the coder, you will have both sites available. The latest update is made for Delphi, but we soon will do that for Lazarus as well. We try, because we are a magazine, to be independent of Delphi or Lazarus or whatever. We want to show things about Pascal development. And that's why we do things in both directions. Now the development we now have made so far is we can do a swipe, which is a movement with a hand up and down. We can do a rotation, and we can do a tap. And the tap is actually the most advanced, because this tap means that you can push something like a button. I mean, a button is nothing but a drawing from a button, and if you push that, it's okay. Now, the first thing we did is this. We made some pictures of fruit, etc. And as you can see, there is a blue line around something if you go to that. It's hard to see. This is the very first version we started with, and it's very hard to handle. It works, but you never know when. It's not precise enough. So during time, we found out new ways of making it more exact. What we actually do is quite simple. We use a method of magnetism, we called it. And magnetism means actually you have an object, like a picture or whatever, and then you can draw, let's say, the attention of the direction into the center of that object. And because of that, you'll be better able to push that button. Now, to push that button, you must realize if you push with, or you're using your finger is never, how to say, still. It's not quiet, it's always moving in milliseconds. So it is a machine, and it notices it's moving. So you have to do something to concentrate the action on a very special point. And what you need to realize is that it works like you cut, if you have running water and you will take a certain cut into that running water, the water still flows. It goes on and on and on. So it's necessary to make at an exact point a cut take out the information and then use it for it. Now the information you have is actually in itself quite simple. One has an axis like this, and an axis up, of course, and an axis like that. So X, Y, Z, or Z, and you can be precise. Now remember, any movement you do, any finger, is information on any moment 60 times per second by movement, which in itself is problematic because you need a large memory, you need quite a good machine to use this. You can't do it on an old one. Under the Mac it works beautiful, but that is because the Macs, most of all, are more acquainted to things like these objects. Now, one thing, yeah?
Is there a way on the driver side, driver configuration of the leap motion to set maximum frame rate? Something like 2 frames per second on somewhere else?
So you could do that in coding.
Yeah, you have to drive it, the logic.
The device itself, you have to install it, of course. There is a driver for it, but it's very simple. It has a very simple interface, and it actually started with gaming. I mean, the device is meant originally for gaming and things like that. And what I found out is that actually until now anything is written for gaming, not for doing precise actions to make a serious user interface, because it wasn't possible yet. It needs a lot of precision, and that's not too easy. We have made available in later versions, which I'll show you, several options to increase things. So you can find out what the best way would be to have to work with. For instance, if you work with magnetism, which is counting the number of pixels that are overlapping, you can increase and decrease that counting. So because of that, you can make it more precise or less. And I'll show that within this session. So this was the old one, and as you see, it has a back. This is too much information coming in, so what I usually do is turn it upside down so it won't have any more information. This is about the ongoing stream of water. It should stop now. I'll have to kill it. Usually it runs for some time because of the lot of information, but the information comes quicker in than you can handle it with your finger. And it usually is because it's still seeing movement. Now, I'll start the latest version to show you some more. Interesting wind. This is the latest version, which some of you already have seen, and we altered quite a lot on it. First of all, we altered, as you can see, the fingerprint. We made it transparent, so it can work actually as a cursor. There is an image in it which you can alter. You can make it smaller or etc. I've just put it upside down, otherwise it will move around all the time. And some of you have seen it already. If anybody, is there a volunteer that wants to try it? Who's freely coming up? Come on, there must be someone.
Hey, Daniele.
Brave art. I think we should do it so people can see what actually happens. Now you put this thing in front of you. This is the axis. And if you go, you can move like that. Just try it. Can you see it good enough? Maybe, yeah, that's. I'll keep my fingers away.
Yeah.
What you want to do now?
Play.
Okay.
Okay.
Yeah.
This is actually
Like
selected.
an apple.
Okay.
You choose.
You're moving too far away.
Okay.
Now, what you can do is, up here you see a little corner, which means magnetism. I'll show you. If you increase that to the double, what's going on? Okay, try again. Yeah, you like pineapple.
Click it. Like this. Okay.
Go to the strawberry maybe. See a piece of cake. Well, you get used to it. But because of the increasing of this, what we call magnetism, it's better able to touch the button. It still needs to be advanced, but you see, you have to make a movement in 3 directions.
So
I'll
the
have some-
select click is on the Z.
Yeah, I'm
Z
in Zen.
axis.
Well,
The
anybody
axis.
does it in a different way. Sometimes people can do it with a very small action.
Or just like a mouse.
Sorry.
Or just like a mouse. Try to do like this.
Yeah. And if you want to develop anything for this, I think it's best. I think it's best to play toys with it. There is also a delay in pictures, which we use to show you how the pictures are developing. I tried to make it visual. I mean, this is not necessary to do. It's just, you have to realize you have to select an object. If you would have a button, not talking to the onion. If you have a button, you have to select that like a normal button. We all know the, what's it called, the range around the button. As soon as it gets selected, it has a selection area.
Focus.
Sorry?
Focus.
Focus.
Yeah. Focus.
Focus. That's right, the focus. And as soon as it has the focus, which you could see like here, the blue thing around it, you can touch that. Now, think of the strawberry as a button, and you will have to decrease that, of course, because otherwise your interface would be huge. Might be interesting for some things, but not for all. So all the pictures I made in here actually are only meant to show you what happens and what the delay is, etc. So this is absolutely just a way of telling you how to work with it, for start. What we will do is make this available as a standard component, which will be further increased in precision and in extra availabilities. What we're going to do is, and that has nothing to do with the leap. We already added a beep, but we will also give it a speech action, so you can snap to it, because we are not only talking about this leap, we are talking about user interfaces. And the user interface should have a mouse, should maybe have a leap. And if you have leap, you can use gestures. And if you have a voice, you could say something which you can use for it. That's a whole different approach, but it has nothing to do with gestures, but all of it has to do with the user interface. There has been some extra development. This was only the tap button, and there are, of course, quite some other gestures you could do as well. And they're even more complicated than this. Trying to go back to the presentation. This is a wired model of your hands. Here you can actually see the points, the red points show you where the action is taken. And this is a drawing I specially made to make it possible to show you how that works. The lowest number of frames that you will receive is 30. So the information available is between 30 and 60 frames per second. We have to find out in what situation the best will be. So what you need to do if you do programming for this, you have to create for each point on your hand a piece of code that is capable of putting the information into the memory, and the memory should be working whilst you're doing your action. The swipe motion, I will show. Oh no. The swipe motion, which means nothing but a hand movement, like up and down. And it should be more precise because actually you want to put your finger on a line and tear it down somewhat, and then it will follow, just like a mouse move. Now, we have done something like that, but it's not yet good enough, so we will have to precise it some more. Put it in action. Ah, that was it. You see? Okay, same trouble again. Because I move down, it's doing all the movement, all the pictures. Shouldn't have done that. I'll turn it upside down.
It's a very nice effect.
Very attractive. And very annoying. I shouldn't have showed this to you because it always goes wrong.
Okay.
Okay.
That.
So we go to the circle. About the circle, I have to tell something. The first thing we did with the circle was actually tricky. You know, if you move a picture, you just turn it around for a quarter, and then you have no problem at all because it shows in another direction. See? So this is actually not good enough. It works, but it's not doing what you really want. You want to make a circle, you want to turn it, and then etc. to make this movement. Now, in a later version, which is better show you another ability. We created something maybe I can do it best with a demo of something very easy. We have a Italian, oh no, it's not an Italian flag, it's, well, some colorful thing. And what you here can do, and that is what we want to do in the next version, is you can pick on and then simply drag it. That's what we really want to do. And we're almost there. But can you see the moire? I'm not sure whether you can see it. If you see the little sparkles in it. This is an error which is still in building up, and what we did is make a better demo. Let me see if I have a better version. And here we solve the problem of information loss, because if you turn something, there will be parts of the picture lost, and you have to do that through a certain algorithm to rotate the image in itself. It is a known trick, but the thing is we want to have our own control about it, so we will inject it into the motion point. Now what you can see here, can you see it? It's a very light line across
Yeah.
and a circle around it. And that shouldn't be on the picture, of course, but if you would do a demo with something, let me start with the normal thing. Here you have no trouble. If you go to this, you see the moire and the demo number 4. You see a bigger circle of what you can do. And now we developed a better algorithm, which is what we call medium. And that means that what you show will be sharper. And the last one, which is fine, is built already, but that means there will be no, how you call that, pixel variation on the edges of the material, so it will be smooth during rotation. Now, we still have only 2D in this case, because we are rotating it by one finger or with a gesture. Now, what we want to do, and that is the next step, is take a bottle or something like that, and then turn it around like you want to. But you must realize you need for that a picture of the 3D quality, otherwise it won't work, of course. So that will be another development which comes next year. Down here, you can see the clock. You can see that it takes quite some time if you rotate it like this. If you rotate it, you can see what the milliseconds are that it really needs to do the demo. I'll go back to this one, and then you can see it takes only half of the time. So the algorithm is much stronger and needs more time if you go to medium, etc. We'll have to find out what the average will be. Sorry. This is the hand access, etc. I already told you what it is doing. It's written in the article itself. And actually here you can see how it is written into properties. You have, these are fake names, of course. We call it center dimensions, etc. So you can figure out where your point exact is and where your information comes from. What's going on? Over here we have a class that gives a lot of properties where you can handle with. You can divide it into whatever things you want. You see stabilized tip position, 3D point, which means we're working with pointers. I hope the idea of Embarcadero to throw out pointers is not going on, because we need pointers even in future, I think. Here you can again see the axis, and down there is a declaration of palm position, so the position of all the things you need to arrange for your own gesture you want to make. I'm not sure what's going on. The hand is divided into several pieces, of course. You have a finger, you have the tool where you work with, you have the gesture and the hand, and it must be recognized in itself. But it speaks for itself. If you install the project, you need to look for the leap controller, which is an essential part of the coding. And the WebSocket leap controller makes it possible to show it. So these are two things you really need in your project, whatever you do, even if you develop your own coding. With Delphi XA5, I think starting at XA, we had a problem because of the JSON controller. It has a different sort of evaluation, because we developed it in earlier stages for the Delphi 7 version, to make it available for all people and to keep it as easy as possible. But then we found out that we needed to make an appropriate alteration to the JSON model, so we introduced that as well. As I told you, the correct hand instances will be stored as a pointer, so you will be able to handle this. Down here you see the pointers: do no frame, do version, etc. The coding itself is very simple, but it took a long time to think of it, of course. Then over here you see actually the movement for the swipe up and down, which is not that much interesting. And then we have here some declarations of gestures we already created. Who hasn't had a magazine yet over here? Anybody has a magazine from the desk? Okay, so you all can have a look at the coding, and it will be updated in the next version as well. If you want to, you can download it after the weekend from the website. This is about the tap point, how to handle this, etc. One thing, if you want to do your own development, you really need to think of is you need to have a point that you can see, because if you don't do that, you never know where you are, even though it might work. It's like a mouse. You don't see the movement, but you are somewhere. So you can make, of course, your own pointer, whatever. You could make a heart or what you want to. Then you probably have seen that already, the pairs, etc. You can do more pictures if you want to. You need some extra thing. But this is only for making your button or creating your button yourself. The samples are all there. You can make your own sort of thing out of it. The banana. And then we have the swipe gesture. In the swipe gesture, you can introduce a friction. So the friction is something like you have in your mouse as well. You can act the mouse wheel very quick or very slow. That is the difference we call friction, and you can regulate that. Now to come to the final part, you can make your own gestures, whatever you want. Of course, it's not capable of doing, well, it might be capable of doing things on your phone. On tablets it could, but on your phone it's too small, I suppose. So I don't think that's a very good idea. But I made some samples over here. You could do a Pascal heart, like I called it, or a Pascal kiss. I just wanted to name it like that because in that case you can do your own and put an event to it, and that event can be as complex as starting a whole series of events or an application or whatever you want. I'll close it. This was so far the thing about lead motion. Are there any questions I can have? Nobody has questions? Okay. I have created also a little game, Pac-Man. I'm not very good at it. It's done with lead motion. And come on. Can you see it?
Yeah.
Too late. Well, anyway. So this is proof that you, in a very simple application, can do this. You will have also this coding available as well for the game as for the lead motion that is packed with this, literally. And what you can do is there is option so you can make the movement slower of the ghosts, so you will have more time to escape. Now, something new I want to show you, and I hope you will give me some answers. about this, what we're going to do. I'm not sure now. Do we have connection? I need to change to the other machine. Do you have something for?
No.
No, you don't?
The VGA adapter.
Oh.
No?
The VGA.
No.
No possibility of changing to.
Serve questo?
Sì.
Oh, perfetto.
Con il microfono push.
Ah, thank you very much. That's me doing well. Can you see it? This one? Oh, this one. Ooh. Um, Can you change it there, or do I need to change it here? I need to change the resolution. Does it work?
No. Good now?
Sorry?
Change the position. The lowest.
Ah,
It's too high.
anyway, in between?
It's not there. Try this one.
Okay, the lowest, yeah. Fine. Keep changes. I've been talking quite a long time to several people that are subscribers, etc., younger people, older people, etc. We all have the same problem, I think. The problem is we do not have a proper help in Delphi, or outside Delphi, or maybe even book form. Some of you might have the older versions, so you will have a book and a version. How much time do I have?
10 minutes.
10 minutes?
Yeah.
Okay. And what I want to show you is something we are going to do in future about this help. And I hope you will like it, and otherwise maybe you can tell me how to do it anyway. So the version I will show you is made for Delphi XA4, We have been trying to do it for Delphi 7, but that wasn't possible because Delphi 7 doesn't yet have the ability we needed for this special thing. I'm just trying to open it. Now this is a sort of project that will take quite a lot of time. Because what we need to do is not complicated but a lot of work. You must see what we want to aim at is that we develop help for all components that are involved with Delphi. These components will have several basic things that we will show. First of all, I'll better open a new project, which is fairly simple, of course. I go to the standard tab, and if you want to use your classical view, divide it into several levels, you could do that as well. It works in the same way. Now, to show you a simple thing, we made it available. You immediately see pop up a window. This window has in the upper corner, where you see that arrow, it's now grayed out, so it doesn't show any ability, but it has the possibility, if there is a project, to show the project. And near to that, the working tools means you can take the actual coding of the help into your project as a comment or whatever. I'll show you. And the triangle there is a whole project that you can load. Sometimes it's complicated to explain a bigger tool, like let's say if you want to show what the possibility is of using just a moment. Can't find it. It's in here. What we started with is writing articles about the more complex coding tools we have in Delphi, like a list box and things like that, action lists, and we write articles about it, and anything that is around it. So if you have two boxes, you can act between those boxes by dragging things, etc. Especially that is sometimes very difficult and necessary to fresh up your mind about that and find out how does it work again. It is now written as an article, but it will be shown in here. It's a bit large now. As you can see, this button copies the sample code into your coding. So if you go and do F12, it should have the sample code. See, down there. And of course, this is a very simple way of showing you, but there are more complex and more components that will do this. In the upper window, you see the component that you're using and the way back, where it comes from, the control, etc. And down there is a list of things you already used before. The hammer means you can arrange for where you want to put it, etc. These are details, of course, that can be altered if there are requests for it. Now, if I go to the T action list, I can show some more. I hope. Yeah. And so now you can see that the triangle is available, so you can click and then it automatically will start opening the whole project, and you can run through the project, try things out, etc. It's and this will be done for all components that are in Delphi. Now, the first idea I had was doing this for the VCL because of the starters. There is hardly any documentation for starters to find, except, of course, on the internet. It's sometimes very poor what you get when you find it. The other thing is, if you using new things like what's it called? FMX, etc. There is hardly any help documentation you easily can use. So we want to put this in. What would be your idea of you doing first? Anybody, any vision on that? Say something.
Well, I'm yet trying to figure out what the target would be. Is it aimed at people that are getting started with Delphi, and it's maybe just replacement for a lacking book how to get started with Delphi because we don't have that many, or is it a replacement for the poor help of Delphi itself? Because, well, that is something people are coming up each year in every new Delphi version, and they were saying, well, yeah, Delphi 7 had such a excellent help, and now I'm using XE, XE2, whatever, and the help is not helping, because often you go to F1 and then it says, oh, the help topic is missing, please help us complete the, well,
yeah,
because,
well, it's meant to do both. What I found out is when you work with something, you often are not into the subject deep enough and you really need help. Whatever, if you're a beginner or if you are very experienced. So the actual question is where to start. We started on doing the VCL. We have planned to do that this year, and it will be ready, let's say, summer next year. So we will have a help system for 520 components of the VCL. Now, what I found out, what some people say is also very important is FMX, FireMonkey, iOS, Android, etc., because there is hardly any documentation about it. But what would be preferable, we need to start somewhere. We can't do it all at once. So what would you say? My personal vision is to do it in let's say, something like FMX as well as Android. sorry, you want a timeout?
Yeah, no, you have 5 minutes for question answer.
Sorry?
You have 5 minutes to Q&A.
Okay, this is the fun. Okay, well, let's try. Anybody that has questions about this or is interested in this project?
I have one question. If we install the Delphi packages, we need also to install the lib motion drivers, or they substitutes?
If you want to build a project for leap motion, you need to install the leap motion drivers. It's in the article, it's quite good documented. Otherwise, just give me an email, I'll tell you how to do that. There are BPL files, and those must be installed. That's very simple. And don't put them in a place where Delphi can't find them, because then you'll have a lot of errors. I've been busy all morning to get in the latest version because I didn't want to overwrite the older version. Then I found out that I was in trouble. Anyway, I solved it. But if you use both of these, the BPL files, it's very easy to install, and then you can run through the coding, and you will find out that you can make your own gestures as easy as that. It's really simple. Of course, you have to find out all the specifications if you want to wipe across on this, or etc. Well, that's how you describe it. Anybody else? No questions at all? Okay.
It's all clear.
Well, if you have any advice or about the help, please let me know. You probably have my address, and otherwise for the leap, look at the website, because we will update it continuously. I think almost weekly there will be news about it, making better solutions, thinking of even more gestures, what we can do, and maybe it's interesting to have some ideas of what you want to use it for, because the user interface is here, but where to use it for. You must think of being capable in this way to handle things through glass or through walls, if necessary. So the user interface can be used in a very different way than you normally think of it, but it's up to your fantasy. Okay, I'll stop here, and thank you very much, and I hope you will see next time. I will see you next time. Next year. Thank you.
to this presentation about WebSockets and also Socket.io. My name is André Busker, I'm from the Netherlands, and I work for 2 companies in the Netherlands, and I had to put my logo on the first page from my website. So what I'm going to talk about is WebSockets. What are WebSockets? I made Delphi implementation about it. I will say a little thing about it, and of course demonstration about with it. Next, and Socket.io is a communication library on top of it. Communication library on top of it, Delphi implementation of it, also some tips on when or why to use WebSockets and Socket.io, and a demonstration. And in the end, I will see how much time I have left a smart implementation of it. Unfortunately, I hadn't enough time to prepare a cloud demonstration, but in theory it is possible. What are WebSockets? WebSockets are part of the HTML5 specification. It's a rather new specification with all kinds of cool stuff for web programming. And WebSockets is a bidirectional direct communication over HTTP. Bidirectional because normally a client can request something from the server and the server responds, but now also the server can push directly data to the client. And this is very important because you don't need long polling anymore. The server can push at any time some data to one or more clients. And direct because it has almost no overhead. Each HTTP call is processed on its own, has its own header, which is processed and parsed and checked. And this is not the case with WebSockets. It's just as fast as possible. It looks similar to TCP because TCP also has direct communication, but instead of TCP, has WebSockets more a stream of messages instead of a raw stream of bytes, which you have to process on your own. The bidirectional full duplex part of the working of WebSockets looks similar to Super TCP, which we also have for years in Delphi and just with normal Windows programming. But at least in Delphi, the Super TCP implementation is quite heavyweight. You have one reader thread per connection. So when you have a server with a lot of connections, or a client with a lot of connections, services, you get a lot of threads. And especially my experience with Delphi is debugging Delphi with a lot of threads makes it very slow. So. Actually, when you look at it, when I start looking at WebSockets, what are WebSockets, how does it work, you think, wait, it's not really new. You can do it already for years with normal TCP in Windows. But it's a very big step for web programming because web programming only has HTTP protocol, and now they have a TCP communication. which you can do very nice things with it. For example, Google have some nice demos where you can use your mobile phone as a controller with your sensors in the of your mobile phone, and then use it directly as a game controller. But you have to be aware that the data is sent over the internet and back to your, for example, your PC, and it's almost a real-time response to it. So that's very cool. One important thing why WebSockets what's important for WebSockets over for HTTP is because it also uses the same port. There were already some other implementations before WebSockets, but they had their own port, their own protocol, own handling, so it couldn't be used with the current firewalls and proxies. Now it just works over the same port 80, and everything works fine in between. WebSockets is not bound to HTTP. It's only the initial connection, the initial handshake where HTTP is needed for. For the rest, it's its own handling, its own protocol. But of course, both client and server has to support it. What looks similar of a handshake? What does it look like? The client connects with a normal HTTP 1.1 connection with the header doesn't get request, but you notice it doesn't start with HTTP, but with WS for WebSocket, and then the server address. You also can change, use other URLs, or so you can make sub channels. Then it's you have connection instead of close or keep alive. Keep alive. It has a new name upgrade. It's screwed, but here you have upgrade to WebSockets. And important for the handshake is some kind of hash, security key which is generated, and the server responds with 101 switching protocols to WebSockets, and also the same hash again hashed to check the same connection. And after that it's done, you have a WebSocket connection. Then the data is sent with minimal overhead, only 2 bytes in front of each message. Only 1 byte is used for an operation code and 1 byte for the length. If it's getting longer and longer, you have some extended length. So only 2 bytes. For the client, there's an additional mask in front of it for some kind of security, which is just an XOR data scrambling. And some kind of opcodes are text. Is it a text message? Is it a binary message? Is it a ping or a phone frame for heartbeat? Then something about the Delphi implementation. There were already some implementations for MD9 and for Synapse, but they were a little bit older. Also supported an older version of WebSockets, like HTML5 specification isn't finished yet, so it is changing over the time. And now WebSocket protocol version 13, if I'm not wrong. And I have just copied some of the code and made it again with Indy 10, so the latest Indy version, which is delivered by Delphi. I have made a separate class, a separate I/O handler. That's the way how Indy works, with separate objects for handling the separate stuff, which can be used by both clients and server. It only has basic support. WebSockets the basic is very simple, but it also has support for extensions like compression, also frame buffering like VNC or RDP, also kind of remote procedure etc. But I haven't done anything at all for that. It's also not very widely used. Only compression, but also compression there were all kind of problems with it. So only basic support, just it just works. And one nice thing you can do with this 10 implementation is that it supports mixed connections. So you can have a normal HTTP connection, but you also, another client can make a WebSocket connection. So you don't have a dedicated WebSocket server. No, you can have a mixed. I also changed the RAMObjects SDK, which is a communication library also, which I have used for several years. I also made a separate channel for it, so it also can use WebSockets. Instead of the Super TCP implementations of Delphi, I tried to make it as lightweight as possible, and I got it working by using only one thread per 64 connections. And the Windows API of the WinSock 2 library also supports this, so you can wait for 64 connections at a time. So only one thread, which is very low overhead. Some demonstration about broadcast text messages. I also have a server, so you also, if you have a Wi-Fi connection, you can test it with your own mobile phone or a laptop or whatever. I also have here a tablet ready. Let's see where it is. So it's just a very simple server with just a memo on top of it. And when we try the first port, I have the QR code here, which you can scan if you want to. This won't work because it has the pulse. Generate scan. So this is the QR code if you want to scan it. Then when we connect to it, we have some simple logging of it is connected, which is connected to, and then we can send some data, and you see it is very fast. It sends the data to the server, and it directly gets it, almost directly gets it back to the client. Also, the text is broadcast to everyone. So if there are other people connecting to it right now, yes, one.
What Wi-Fi network are you?
Excuse me?
On which network?
The ITDevCon.
And what's your IP address? Because you were too fast.
Yeah, sorry, it's on top of it here.
Okay, 104.80.90. Okay, great.
Yeah. Testing it, but as you see, it is pretty simple. It's just some text is sent and is received, and well, that's it. Maybe I don't know if I send some data. Probably others are receiving this too. But at least this is, yeah, what as you see. It's pretty simple. It's nothing more, nothing less. It just works, but nothing really special actually. Only the pushing from the server to the client. That's new for HTML for web programming. So when I started the WebSocket, I also had that idea. Okay, nothing more, nothing less. So what's next? And then I found out Socket.io, communication library. This is a JavaScript library, and it works on top of WebSockets. It's a JavaScript library for Node.js. It's a server-side JavaScript library. Also has a client part of it, so you can use it on a web browser for a web client, for mobile devices or whatever. And the nice thing about Socket.io is that it works on every browser, or even EA6 it works.
Whereas WebSockets, you need a browser that is capable of it. The new EA10 and the new Android and iPhone already supports WebSockets, but if you have a little bit older Android phone, Android 4.0 also doesn't support it. But Socket.io also has a fallback for by using HTTP long polling and flash sockets, so it works on every browser. And this makes it very more, you can use it, it's better usable. It's completely event-driven and async. I have here a little JavaScript load. You connect to the server, to a port, but because it works on top of HTTP2, you don't start with WebSockets, you just connect to a server and then it will find out what kind of protocols the server can do. And when you have a connection, I missed the connection event here, but when you have the connection, you can register, listen for an event from the server, and when you get that event, you get the data in some kind of anonymous method. The client can also send some data to the server with an event. You have some data as parameter, and also can request and acknowledge from the server. You can also just send some data and don't care about when it's finished or the data, but normally for a client you request some data from the server and then you get, in acknowledge, you get your data for shown on your web page. The protocol is different to WebSockets, it's just a separate protocol. It's very simple, text-based. Just one is connecting, 2 is a heartbeat, 3 is sending a simple message, but you can also send a message where you want to acknowledge from the server. Then you put a message number and a plus sign behind it, so the server knows plus sign, wait, he wants to acknowledge. You can also send it to a separate room, and then you get the data back, the data you sent to the server. You also can, this is just a text message. 4 means I want to send a JSON message. 5 is sending an event with some arguments. Here you have the same message number, because here I have message number 1. The next will be message number 2. And with again some JSON with some kind of arguments, you send the name of it, and then the server or the client can respond with number 6. With the message number it responds to, which is the same as this number, and the data it sends back to the client. So this is also pretty simple, also quite easy to implement in Delphi. The Delphi implementation also is done with ITDevCon. It uses the same WebSocket.io handler I made previously, but I also, in the previous week, I also implemented the HTTP fallback, so it also works with older Android phones or older browsers. It has a separate Socket.io handling, separate unit, which also is shared between the server and the client. And it has only, again, some basic support that just made it work, but nothing more, nothing less. So it has no room support yet, no subprotocols, no authentication. Socket.io itself has many more options you can use. And like WebSocket, you can make a mixed server. So one server, one port, with HTTP, WebSockets, RAMobjects communication on top of it, and Socket.io connections. After some time, after using Socket.io, I got quite enthusiastic about it. It really works very nice. It's very easy, especially sending from the server to the client is very powerful. Can really make cool stuff with it. But the only thing, the negative part of it is that it's
don't have type safety, just JSON, you have just as hard-coded strings for your event names, so you have no type safety at all. I'm thinking about using interfaces on the Delphi part and using the T virtual interface since Delphi XE3, I think, which you can catch the interface call and wrap it into some kind of JSON interface and generate the socket I/O call to the client and the server. But that's not ready yet. An example of how some data flow looks like. I have chosen to add a separate property to the server, socket I/O, so you have with code completion you have the own separate functions available. On events, you have the name of the event and anonymous method when you get the data back. As you see, it is more text. This code is type safe. At least callback. In JavaScript, it's much easier to generate an anonymous method, but also you don't have type safety there. You get the data in a super array. I have chosen to use super object, open source Delphi library for JSON, and you get a callback function. And yeah, I don't check it here, but actually you should test if the callback function is filled, because then the requester wants to have callback, but he also can make a request for this event, but with no callback delivered, and then also this callback function will be nil, will be assigned. But anyway, you can directly send the response back or later, doesn't matter. You also can stop it in a timer or whatever, and send the response later. And this is the way super object works with just a function, and it results with a JSON object. The cool thing is I made it, or at least the customer I work for, I made it open source, so you can download it and use it if you wish. I've posted it on GitHub. It's just very cool, new kind of sharing. So you can fork it and then add some changes or make some modifications, and please send me a pull request and I will merge it into the main repository again.
Andre, sorry.
Yeah.
It is supported also normal HTTP functionalities.
Yeah. Sure.
So it is an HTTP server with.
Yeah, it's actually just the Indy 10 HTTP server with separate. I just added used the WebSocket IO handler, and I added the socket IO object to it. So it's just normal Indy 10 program. So you can already replace it and then later on use it. Why or when to use? Because WebSockets and Socket IO is more about JavaScript and web programming, but it's also very useful for just if you use the Delphi for everything. For example, Windows services. I make a lot of Windows services, but one thing about Windows services, it doesn't have a GUI. Just a background service, and it has no front end. So normally I make a web front end for it, so you can at least see what it's doing, what's the status, the messages it has logged. And in that case, when there is an event or there's something happening on the server, you can directly push a new message, a log message, what's happening. So that's very useful for, and because it can use it as a mixed, because it supports mixed server, you only have one port and you can use it for everything. For normal HTTP for delivering static files and JavaScript and CSS files for your web front end or other front ends of thin clients you make. Normal WebSocket communication, which you can use with, I put it in on here, new web clients, new Delphi clients, because Socket.io I'm planning to use for new clients to use Socket.io instead of Vim objects.
Like I said before, I made a MacOSX channel which works both over HTTP and WebSocket, also for the client version in JavaScript, which you can use. So you have one port, and you can serve a lot of different kind of clients. And because when you make an HTML5 web app, you can of course use with the newest version of Delphi x85, you can make an Android client lane, but one thing that bothers me is the big executable size of it. And when you have an HTML5 web app, I would advise to make a single page app. That's what's currently mostly used. You make just an HTML5 of several HTML5 HTML files with some JavaScript, and only connect to the server to get some data. So you don't like with PHP or ASP.NET, where the server page is generated completely on the server, and then the generated HTML is sent to the client. With this, you have just local on your device your HTML files, and only using JSON or XML, you only fetch the data. So also when you are offline with your Wi-Fi connection or whatever, when you have connection, you can again get some data. The biggest benefit of this is that you don't need an app store. You can run it on any device for all kinds of mobile devices or web browser on your computer. And this is the biggest benefit, especially when you have for iOS, for iPhone, you don't have to wait to ask Apple for when you have a new update to push it, to release it. Another example is I made a Flash replacement because Adobe Flash doesn't work on iPad, or iPhone, or new devices. So you have to replace it with something. In the newest Adobe Flash Designer, you have an export function which you can download, so you can export it to HTML5 canvas library named Create.js. And I tried that, and also made a Node.js and a WebSocket server, which can directly send all changes from the PLC to the visualization. So you can see the visualization, which is just a normal, which was before a Flash file exported into HTML5, and you can watch it on your mobile device and directly see the changes of when something changes in your factory plant. And there is also another NoSQL presentation this day. Also used MongoDB which is completely different kind of database storage. You can't compare it with normal SQL databases like Interbase or SQL Server or Oracle, because you just stored all kinds of JSON documents in it, which is very useful for several kind of implementations, not for every solution situation. Okay, I have a second demonstration, which is a little bit more cooler. Nice messages on it. It's the same port, but then with port 1891, which you can try. See when the first one pushes the button. At least I hope it does. Yeah, there it is. And I hope you can see that it responds quite fast. At least on my local computer, it responds very fast.
Let's see if this one does connect. The other one didn't connect at all.
Okay, I'm sorry.
Yeah, no problem.
So at least this one works. This is quite nice. Well, of course, it looks nicer, but because I use an Gauge and jQuery mobile CSS on top of it. But at least it also shows how you can make a dashboard, web front-end, web dashboard, which can be viewed on every mobile device and directly responds to any change, whatever you want to send off to visualize. Nice stuff to play with. So the next part, how much time do I have? A lot of time?
How much time?
30. Yeah.
30 minutes.
I'm going too fast. I want to show just a simple HTML5 client made with Smart Mobile Studio. The best thing about this is that you have the full client-side Socket.io implementation. The same for the server-side Node.js implementation, because I re-implemented the Socket.io library in Delphi, but in Smart Mobile Studio you can use just the existing, extend the complete full Socket.io library, which is already present in JavaScript. Some little thing about Smart Mobile Studio for those who haven't heard of it at all. And just in short, you can just use your Pascal, the Act Pascal language skills, knowledge which you already have. But it also has very nice improvements on top of the normal Pascal language you have in the latest Delphi version. And I like the most thing I like are inline variables, so you don't have to put all variables on top of your procedure. You just can put new variables inline in your code. Also type inference, so the compiler will decide, will check and fill in the real type of it at compile time. Lambda expressions, which is, I haven't used not a lot already. And it compiles to JavaScript. You don't have to know any JavaScript at all. You just can program in your Pascal language and compile it to JavaScript. There's some cool features like smart linking, obfuscation. You can also call, just directly put in some JavaScript, which if you have some code on the internet, you can make an assembly section and put on the low-level JavaScript into it. And it also has support for external classes, etc. So you can easily make a wrapper for an already existing JavaScript library. And I think it is the best of both worlds. We also all love the Pascal language, and JavaScript is very weird to work on it. It's very powerful, but it's not typed, so you can't check and compile if it still works. You only get runtime errors. And with this kind of solution, you get at least the compile time errors. Node.js is, you really have to play with it and get into it, because it's very different to normal JavaScript program, or at least web browser programming. When you're used to web programming, it takes some time to make the switch, because Node.js is just the JavaScript language, and it has nothing to do with any web browser at all. It doesn't have a document, it doesn't have a window global, it doesn't have any DOM, so you can't use jQuery. It also doesn't work in the sandbox. It just have full access to all files, all servers, processes on the server, etc. It runs on the Google V8 engine, which is very fast. It compiles almost to native code runtime and just-in-time compiler. And it has a garbage collection, so you don't have to think about freeing or your objects. It is also with almost everything in JavaScript. It's event-based, it's async. It has its own API for all the file handling and for the process handling, which is very dedicated to Node.js way of doing things. The most important thing you need to know about it is the user code is single-threaded. It's the same in a web browser. When you have one tab or one page, it is single-threaded. That's due to the Google V8 JavaScript engine. But it can handle all async stuff in separate threads. So when you keep your own user code small, into small sections, small functions, or waiting for async events, it is really very fast. There are several comparisons with other HTTP web servers, and it's really in the top of it. And when you need some more power or whatever, you can easily fork it, so you get all kind of parallel instances on the fly. But because it's single-threaded, you don't should do any real big compression or calculation because it's single-threaded. So demonstration of it. I've closed it. Let's see. First, the server side. Read the code a little bit. At least it looks a little bit like this. You create. Where is my mouse? Create a server. Normally, in this case, I just respond to hello world. So if you connect with normal HTTP web browser to it, you get hello world. But it also has a socket I/O listening to it, and it waits for an event request from a client, and when it gets, it increments the value and it does some logging, and this is a callback function. It calls the callback function to send the data back to the client. Here's some client-side code when connecting to it and sending a request to the server and updating some progress value. And it looks like.
Could you increase the font size, please?
Oh, sorry. Going too fast. This is what it looks like. And when I run this, first I have to run the server. It's just on console or servers, Windows servers. Then I start a client. It's just do the same port twice. Debugger. And the first time it takes some time to connect, and after that it just works. It's just a very simple demonstration, a little bit like the same with the courses, but only with a progress bar and button and a label on top of it. Just a normal, so some components I dropped on the forum in Smart Mobile Studio. So it works. was my presentation. Anyone having some questions or remarks? Yep.
In your experience, we know that Node.js architecture is fast for smart requests and so on. But in your experience, if I need the messaging as a part of my application, but in a normal application with heavy request, access to the database in a easy way, and some other stuff, and messaging based on, let's say, Socket.io,
yeah.
Smart Mobile, and so on. Which is the best match for the two worlds? Smart request and heavy request, lower, fewer but heavy requests.
Yeah, Node.js is very good for simple, small calls. Yeah, but when you have a lot of existing server-side code or functions or whatever, yeah, for normal and real business application, I would say program it in Delphi using the Socket.io extension library on top of Indy10 for the full processing. But yeah, one thing I forgot to mention, the Node.js is very good for website, for web clients, and it is very it's mainly used in cloud. So it's very easy to generate the JavaScript. You can copy and paste it in the Windows Azure cloud or whatever. When you press on save or publish or whatever it is called, it is directly, you can directly scale up to thousands servers at once. So that's the biggest benefit of Node.js. You can easily run it and deploy it in the cloud. But it's also very tiny, so you can very easily run it locally. So it depends on what you really want to use. But for now on, I tend to, for real business stuff, just to keep it in Delphi, and for visualization or other smaller kind of projects to use Node.js, because Node.js is very good for that kind of stuff, for prototyping, trying new stuff, mobile clients, etc.
Okay.
Yeah.
Does it work over HTTPS in addition to HTTP?
I don't know. I don't think my Delphi implementation works.
No,
but normally it should. Yes.
Okay.
Yes.
Because security stuff.
Yeah, it's important. But like I said before, it's just a simple implementation. I just want to get it working, and.
No, I mean in general, security
yes.
is important.
Yeah, especially when you have.
I mean, this is for demonstration purposes only. So it's I get it. It's not HTTPS. Because that would take much longer time and certificates and stuff like that.
But at least the Node.js implementation already has support for HTTPS and the WebSocket WSS for the secure communication. So yeah, when you deploy it in the cloud, I should use that kind of. Yep. Any other questions? Friday midnight.
We arrive at the break early for a change. You did well. Thanks.
Okay. All right, it's last session of the day. I hope you can all have a little bit energy left to listen to me. It's a RAD session. There are some low-level things about profiling. I think the most will, at least I hope you can at least understand the most things. What I want to talk about is first some introduction about profiling in general, some thoughts, some experience for myself. First technique is about just using the Delphi IDE itself, then something about sampling profilers, followed by instrumenting profilers, some general tips I learned in the past about just some little things which makes your code faster. Some list of other tools I use some now and then, and if I have some time left, maybe I can tell a little bit about Intel VTune, but that's really low level. First of all, I want to complain about this sentence. I heard that too much. Perimeter optimization is root of all evil. Yeah, I don't like that at all, because so you should not do any optimization at all. Should you just start programming? Don't think, just go ahead. I don't like that. In general, I don't like black or white. Mostly the truth is somewhere in between with everything. But at least the most important thing you need to know is know what you're doing, what kind of code you write, and know what you're doing. A lot of, in .NET at least, I heard complain, for example, about LinkQ. It is used too much, and when you look at the generated code behind, it's so big, so huge for just a simple search function, for example. So some little things you also have to know by experience, what things that are bad or good, or what to use or what not. At least when you start programming and you have to add some functionality, you have to think about, okay, how fast should it be? Is it used for a button click on an about box, or is it a server-side function that is used a lot? It makes a different approach about how to make your code. At least I do. Normally I try to start just the default Delphi structures like T-dictionary or just strings, etc. Just to keep it normal, because you can change that kind of code very easily afterwards. If you directly start pointers or p-chars or whatever, and then you get Unicode conversion with Delphi 2009 or with 64-bit or with REM. If you just try to use the default structures of Delphi, it's easier to change it afterwards, especially when you use agile programming. It is easy to change those. So there's a little bit balance between just started to do it normal and fast with the default structures, and afterwards when it's too slow, then you can start profiling and really go to the last lines of code. So don't really directly use pointers or assembly or whatever. Only when you are making some kind of algorithm or a compressing function or whatever, then you really know in advance it must be really fast function. And think about the architecture. When you're starting a new project from scratch or changing your architecture, you really need to think about architecture. When you just have one little function, you can change that function very easily afterwards. But when you can't change your architecture very easily afterwards, and at least what you should not do is use chatty interfaces. So little small calls to the server, because each call has its own overhead. So try to combine several things in one call. And at least my experience is abstraction is fine, is cool, is nice, but it also has its price. It's almost always, at least in my opinion, it adds extra overhead. You can't make an abstract function which is small, which is faster than a normal direct straight ahead implementation. So and keep things simple. I met programmers who made fabulous functions, technical, perfect, all kinds of which are spread out of several units, several classes, just to read a file. And okay, why can't you just use a t-string list and just do some little copy pos function and then you're done, because it's just a little function you just need once. So that's just keep it simple. Makes also easier to change it afterwards and to use to get used by other people. And think about quality metrics. You can make something very fast, but most times when you make something fast, it's less easier to read or less easier to maintain, especially when you talk about scalability. I made a function who spread it out, the compilation, the computation about several threads, grouping several functions, doing all kind of database stuff, but it was almost not easy to read and also not easy to maintain. But the speed was the most important factor at that point. So you have to know that you can't have all of them. You can't have a scalable function which is also very easy to read, or at least less easier to read than a normal straight ahead function. And when it gets slow, don't bother, don't be afraid. Sooner or later your code will get slow. It's not something you can do about just over the time. User requests are changing, so your code is differently used, you get more data or whatever. So sooner or later your code gets slow. Everybody probably will have some kind of code which you think, hey, it's slow, I need to profile it, I need to optimize it. And it's also not to be ashamed of. You can't know the future. But you have to, when it gets low, you must change it. And then you start profiling, or at least think about optimization. A lot of big mistake of it is just look at the code and say, oh, wait, I see it, it's just there, it's because of this, that's why it's slow. How do you know? Yeah, it's probably because I heard it too much. And so don't look only at the code, but also measure the code. When you don't measure, you don't know exactly what you're talking about. And most times it is in the least expected place. It's very fun to, when you have a customer and say, yeah, I know where it's slow, it's probably there, and when you look at the code, it's completely somewhere else where the customer doesn't even know it existed. And fortunately, mostly the changes are fairly small. You can optimize your code with only some small tweaks, and then it's get a lot of faster. Some examples. My first experience with profiling was optimization of a SAP synchronization. It was done during the night because it was, I don't know it exactly anymore, it's more than 10 years ago, but at least it was more than 8 hours. And when they started the evening, the next morning it was finished. And they asked me, can you look at it? Yeah, some other experts have already looked at it, and probably there's some kind of SQL Server optimization you need to do, some index or whatever. But when I start looking at it and start profiling, it hadn't anything to do with SQL Server or whatever. It was the synchronization, the connection with the SAP database itself, because they didn't connect. They fetched a single fields, only the address or only the city or only the postal code, and then they disconnected the connection again. And each connection costed half a second. And then when you have 100,000 customers multiplied by at least 3 fields you want to synchronize, you can imagine it takes a lot of time. So when we just changed it by just connect it, then do all the fetches and just leave keep it the same, and then just disconnect it at the end. Then it took about 45 minutes. So the customer was really astonished. It's just such a simple fix for the problem. That made me really enthusiastic about profiling, and so I start why I am standing here. More recently, I had complained about a customer I was attending, and he said, Andrew, can you help me, because we have a slow import, it's too slow, and yeah, we use your new framework, but yeah, you use too much small objects and it can't be fast. Alright, let me see, just start profiling. I don't, sometimes can be a little bit arrogant. I don't trust you, I will see it myself first. So I start profiling, but they was reading a very huge Excel file, and yeah, Excel with the OLE or ActiveX or COM or whatever communication it is, it's really slow. So I said maybe you can try another technique, and TMS has FlexCell, which reads natively in an Excel file, and which was way faster. So the customer was happy, but the next day, yeah, it's still not fast enough. No, all right. Yeah, probably it's because you are generating a lot of simple update and insert statements to the database. You should combine them and make a batch import. All right, arrogant again. I will first see it myself. I start profiling again, and the problem was they had a hidden debug memo form where all SQL statements were logged into, and it was hidden. So it is hidden. So it should not take any CPU cycles. Yeah, right. You are adding a lot of code to your memo. It can't be slow. And after just disabling, it was fast again. So that's why I want to stress. Most times it is at the least expected place, and small fix can do a lot. Another interesting thing is about some kind of business object that was made by another architect, and we had a great idea about business objects. You have an order you want to load, it loads all kind of details and order lines at once, and then you can start working with it, and all kind of business logic is in it. Okay, but then a programmer just needed to show the order number in some kind of logging. So we had the identity of the database and just want to show the number or the order date in the logging. So he created that business object, loaded completely order in memory over the loading all kind of details, and then freeing the object. You can imagine it's very slow, and you load all the data just only for one field you want to show. So I changed it to make it selective load, so you could change, alright, I want to load an order, but I only need the order number. And later on I made just a small function, okay, give me just the order number for this identity. It's some kind of small changes you can do, but when when the program doesn't know the impact of it, what the cost is to load a complete business object, or how it can do better, maybe he should think a little bit more and think, wait, this can't be fast, so I should use another function. But so just know what you're doing and think a little bit about what you're doing. The first technique to profile, to actually debug it, is just use the debugger itself. Just pause the debugger. And it's a very simple technique, and I learned it some years ago from Andreas Hausladen. Everybody probably knows about Delphi speedup, ITDevCon, DDev extension, etc. he made. And I asked him once, how did you do that? How did you find those bottlenecks in the Delphi IDE? And just say, well, just pause the debugger. How do you mean? Just load Delphi within Delphi, run it, and when I think it's slow, I pause the debugger, and then I look at the stack and see what it's doing, and just doing that a couple of times, and then you know why it's slow. Wait, it's just so easy. It's almost too easy, but it's I use it a lot. You have to know it's the chance to get it, because when you pause it, you should do it a couple of times, because maybe you have a tiny function you have trapped, and then look at the stack and then think, okay, that place is slow. And I really can recommend to use the F12 key. In Windows XP it was very good. Defaultly on when you are running a program, you press the F12 key, it directly breaks, stops into the debugger. But with Vista, Windows 7 and probably Windows 8, it doesn't work anymore. Fortunately, Andreas Hoogland made a small fix, small library you can download and install, which is called the Delphi F12DB debug hotkey support, and I use it a lot. When you have, for example, when you click on a button over here, you have a pop-up menu, and you click on it, and it doesn't really pop up directly, but it takes a second. You can't pause the debugger by pushing the pause button in Delphi IDE directly, because within a second it is already gone. So mostly I click on the button, wait a half second, and then directly press the F12 key. Then you can very easily trap where it is waiting or busy with. Next is sampling. Sampling profiling tools are mostly separate tools. They run separate from your own application, and it takes samples of the stack as fast as possible. But you only have a resolution of 1 millisecond. You can't sleep or wait. So mostly the most sampling profilers can take up to 1,000 stack traces per second. Nothing more. The benefit of this approach is that you don't interrupt or modify your own application. Your application doesn't know it is getting profiled, it just runs at full speed, and just samples are taken outside its application. And you can, in this way, because you have a full stack, you can show all functions that are called, all DLL functions, even within to the database, drawing, GDI, DirectX, whatever. But it is only caught when it is within those 1 millisecond time frame. Not every tiny function is ignored, but it's also not important, because those tiny functions you are not interested. You don't get real timing information about the function, only an estimation, because when you have trapped a function 10 times consecutively after each, then you can say, oh right, probably the function takes 10 milliseconds, but you don't know exactly. Some common, when you start profiling and use profiling tools, some common information, what is used by most profilers, are the function name, unit and class name, of course, and a hit of sample count, sometimes some kind of estimation of the duration of the time, and mostly also the percentage of the time. Sometimes it's broken up in two components, namely the own time and the child time. Own time is actually your own execution, your for loops, your if statements, calculations, whatever in your own body of your own function. Child times are all the functions you call within your function. You can have just a button click which calls another function which takes a lot of time because of all kind of database communication. You want to know it is that button click and where it comes from. But the button click itself has no own calculation in itself. Some profiler tools that are available, at least for Delphi, is the Eric Range sampling profiler. It's free, it's small, easy to use, you can just download and run it on a production server. One cool thing is it has an own online internal web server, so you can run it on the web server, and when it's about some kind of threshold, it starts profiling. It has a very low overhead, and you can remotely watch the results. However, I don't use it a lot because it only shows the top function. I asked Eric about it from, wait, why does it work this way? I don't get the expected results I expected to see. He said, I only get the top function, but what the function is execution now, and its parent function, and nothing more. So not the whole call stack, because that's not 100% reliable. So, but the downside is you miss a lot of information because you don't know where those sleep or where those database functions is called. It is useful when you have computations or whatever of calculations. Then you want to know which line is taking the most time. AQ time is bundled with Delphi. I don't know if it's bundled with C5. Yeah, I think so. But it is commercial, and normally you only have a standard license, a standard version. So you need to buy the fuller version to get the real potential of it, and it's big. It needs an installation, so you can't use it easily on a production server. And most times it is slow at the customer. It's not slow when you're testing it because you have less data or other data or whatever. But most times, at least in my experience, it is slow on the server for the customer. So you want to profile there. And yeah, I made my own sampling profiler. Open source, it's free, no installation, etc. And the biggest benefits, at least my opinion, is it's very detailed. It catches all stack frames, it shows all stack frames, so it's per thread, so when you have multi-threaded programming you can watch each thread which functions are called. And so no summary or where there's summed above for all threads. However, sometimes I have also encountered it in my demo, it's not 100% perfect. Sometimes when especially when you call DLL function or Windows APIs, sometimes the stack is just broken. You can't do a full stack trace because the CPU, the stack is just half a computation, so it has stored some random data on the stack, so you can't see further than that. And then you get some weird results. You have to know it is. I try to show as much as data as possible, but you have to interpret it yourself. I can't. I'm not responsible for 100% good results. I made it for my own, so probably it's less easier to use, and at least Eric Green's tool looks nicer and it's easier to use, and probably my own tool is not. But I will try to show how to use it, at least in here. I use GCL debug, the .pas of the GCL framework library, and it has support for a lot of debug symbols, at least for the default Delphi EMF files. You can compile GCL debug files, TDS sections, TDS debug information of Delphi, remote debug symbols, DLL exports, PDB, Windows debug symbols, etc. For the best results, it's best to use stack frames so you can make better stack tracing. At least GCL debug can do it better. And one tip, at least for productions environment, when you have some kind of build server and continuous integration or whatever solution you have, make use of the make GCL debug.exe of GCL library, where it compiles the map file, zip it, make it smaller, and then injects it into the executable. So when you have an executable, you have the real exact debug symbols of it. Most times when I started, you had a separate executable and a separate map file, but other people just copy only the executable, and you have a version mismatch between those files, and then you get incorrect results. Alright, in demo, see if it works. I have a VMware here, where I have several functions. If I'm correctly wrong, but at least the source code will also be on the USB stick, I think, so you can watch it later. I just have a simple button. We have it will sleep, it's slow. So I press the sleep button, it is slow, it doesn't respond anymore. And then I press the F12 key to directly break into the debugger. You have to switch to the thread pane, because it stops in a separate thread. Then we go to the main thread. Here we see where it is waiting for. We have our button one click, and it does some kind of sleep function. So at least I can see where it's busy with now. So that's just simple trick. It's busy for a couple of seconds. There it is again.
Sorry.
Yeah.
Before we move to more complicated with stuff. One other simple trick,
Yeah.
if you have a long function, which is too slow, and you know it's this function, but you don't know where, is to put few breakpoints inside it, and then just press F9 and
Yeah.
see which parts are taking long.
Yeah, there are several kind of things. You can also log, use the new diagnostic. So there are, of course, there are several. It is not exclusive only these kind of techniques, but
No, of
there is,
course.
yeah, I
That's
use it.
that's something I use.
Yeah, I use it. I use it too. So thank you. One common thing I see a lot is when you have, for example, for loop, which takes 100,000. Let's see what it does. Make the font a little bit bigger. Where is it? Don't use this a lot.
Display three notes down.
Yeah. Okay, thank you. It's better. Well, it's just a for loop, 10 million times. It's executed, and as you see, it is quite fast. It's only a couple of milliseconds. And then I want to show some kind of progress because the user wants to know what's going on. And then the same for loop takes a couple of seconds. It's just the same for loop, just updating the progress, and you really think, what the heck is going on? So use the same trick again. At least you get a lot of. I don't even see my own function again because the stack trace is a little bit screwed. I think here's my control click function. And then the set position of the progress bar is called. It's called a lot of other Windows API functions, and it paints something. At least it is. No. At least it takes. Yeah, I did it, but at least it takes a lot of seconds. So when you do this kind of stuff, I usually use this trick just not to paint every time, but only when you have thousands, each thousand of iterations. So not each iteration. Then you see it is already faster. No, click it twice. So it's just a small trick. But I see a lot of programmers just update the progress every time. And when you have millions of updates, it's getting slow. Of course, I can use my profiler to use it. I put it back a little bit, make it a little bit slower again. Here's my separate sampling profiler. It has a couple of buttons. Tried to make it a little bit fancy. At least what I use is stack view of process. Just my process in it. There's no filtering in it or whatever, but at least it works. Double click on it. I can see where it is busy now. You can also automatic refresh, store rows, stack tracing to get a lot of data. And then I choose profile it. But the trick now is you have to start profiling it, but yeah, you have to do it when it's busy. So I start this, switch to the other, start sampling, and most times just a couple of seconds is enough to get an idea where it is busy with. Don't have to do it for a lot of time. Then you click on show results. I can't increase the font size, I'm afraid. Maybe I can use. It's not readable. Is it readable? I don't think so. Yeah?
You just care what's written.
Yeah, we'll see if I can find my tool. Where is it? Come on. Okay, so let's try this one first. No, it doesn't work in VM, I think. Maybe switch to another tool and then, yeah. Alright, here we have a better view of it. Here you see the main thread is using at least 3 seconds, was busy. Other threads weren't busy at the moment. And then we see at least some Windows API functions where it is busy with. And then we see some kind of button click. Just only a flat list of it. And this is the one where it says the own, where it is calculating or waiting or busy with, because it has an own time. All these others are just because of the child time, because these functions called. When we double click on it, we get a list of every stack trace, every sample it has taken. So most time I just take a look at it, just seeing where it is busy with. Then you see here, yeah, again my progress bar, then it calls a lot of functions. So you have to read a little bit, know how to interpret a stack trace to get used to it. So, as you can see, a lot of samples. They all come here, so I know it is on this position. But as you see, stack traces are not 100% exactly, because I miss my button to click here. So that's a problem with stack traces sometimes.
Andre, is it problem with the stack tracer or with also the sampling profiler from Eric Granger?
Yeah, Eric Granger is even, yeah, I don't like to say it, but even worse. Because it would only gets this function and this function. Only the top function that would call. So you can't, it doesn't look further than this. So, but it's just more a general problem, because somehow I think this kind of function pushes something on the stack, so you can't do a good stack traverse with a good stack trace. But it's really something to do with how the assembly code is generated. Some low-level stuff.
Did you turn off optimization?
Yeah, I think so.
Because that makes a difference.
Yeah, I know. I have the debug function here. Debug configuration. I have stack frames and optimization off.
Okay.
Yeah. But indeed it can make
You just learn to ignore the noise when you do this.
Yeah, especially when you use, for example, when.
What are you using for walking the stack frames?
This is the DCL function for it.
Okay.
And I make, yeah. There's also some kind of stack walk function API of Windows, so sometimes I try to use it, but not always it works. How doesn't it work? Well, it even crashes. So it's just added it as a test function. Well, I can show something more. Maybe I can show, instead of Excel, I only have OpenOffice. I don't want to pay Excel because I don't use it on my own laptop. So I use OpenOffice. Just to mimic the import problem that the customer has with opening an Excel file and reading the data from Delphi using the overlay communication. So here, as As you can see a little bit here, it is busy. I think. Well, it's finished now. All right. But at least just a simple test function. It takes a couple of seconds. So I should start my profiler now. And then you have the timing problem. Because I need to start it and push the button. And when it's finished, yeah. And when we show the results, we'll increase it, try to increase it. Yeah. At least we see our button click here. And yeah, there was a lot of was busy with not 100% of the time, because when I started it and I pressed the button and stopped it again, it was already done with it. But at least I can click and see what it is busy with, all those stack frames. Just try and view some of them. And as you can see, some kind of cell text is read, and invoke is done using variants, and then we see a lot of Windows DLLs function called to get the data due to communication with the other process, etc. At least I wanted to show that it's slow. You really should not use this for some things. You can do it, but when you want real fast speed, you shoot some kind of flex cell of TMS or other kind of things. Now the other one. All right. Then we take it to the next level about instrumenting profilers. It's a very different kind of way of profiling. We have two kinds of profilers within instrumenting profiling. First are source profilers. They modify all your source code. They put in the beginning and the end of every function you want. They put in some extra code, so every call is logged into some kind of log file or whatever. The benefit of it could be, I'm not sure about it, but at least the compiler can compile all the code, so it should optimize the function calls. And you should be able to port it to ARM or 64-bit. I don't know if Pro Delphi does it already. At least it was the first profiler I used. I used this for the SAP problem 10 years ago. I haven't used it really much afterwards, because it changes all your source code. And if you have a very big library of all kinds of functions, you don't want to change your complete source library in one go. Next are binary profilers. IBM has an on-disk profiler, which takes all your DLLs and the executables and store them on disk, so you can just run them afterwards. And then like a QTime or my own profiler does it only at runtime. So you don't change your own executable, only runtime in memory. The downside of this approach is it's very CPU specific. I don't have a 64-bit profiler yet, because there's different kind of stack handling, and just the assembly is very different. And you also can't profile small functions, because there's a jump, assembly jump inserted into, and this takes 1 byte for the jump instruction to the CPU and 4 bytes for the 32-bit address you want to jump to. But it's not a big problem, because those tiny functions you are not interested in at all. Some tools are a QTime and again my own profiler. The downsides of instrumenting profiling is you have to manually or automatically check every function you want to change. You have to give a list of functions. Most times you can just select a whole unit of them. Just say just try to profile every function. And the big change is the real execution is changed, because you insert a jump into in the end of it. You do some logging. There is some too little or much overhead per function call, especially very small functions. They are doubled or even more. They get a lot slower. Also because the CPU has changed. The CPU can't do a loop very fast anymore, because it's every time it's jumping, it's interrupted. And the CPU cache has changed. But at least you get exact function times, especially when you have some bigger, larger functions, you get exact function time of it. And you have to switch to delete all those tiny function calls, because they are interrupting, they give an imbalanced tree, they give some noise to your output. So you must really be aware of when you have a lot of tiny function calls, you should delete it and do a profiling again. I once tried to optimize a function and saw many function calls, and I thought I should optimize it, why is it slow? But when I run it without a profiler, it was already fast. So don't you have to be aware of that. And because you get every function call, you can also get the exact the execution time, also the number, the calling count. Where the sampling, you don't know the real calling tree, but then you know how much times a function is called. And you can make a trace tree. My profiler is a DLL, which is loaded into the executable, so it can do the in-memory changes of every function. It's binary, and well, it's a little bit in the name. It's using assembly to hook into, to detour every function call, making a jump, making a sample line, modifying the stack return address. So when a function is done, it gets into my own end function, so I know the start time and know the end time. A little bit low detail, but at least that's in a nutshell how it works. It stores every call. Other profiles don't do that, but my profile stores every call. That's the detail I want. I want as much detail as possible, and I didn't like AQ time or other profiler because I missed the detail. So I start thinking, maybe I can make my own profiler myself. Several years ago, one downside of it is it uses a lot of memory. So when you run it, you can run it for a couple of seconds, maybe a minute, but you see a steep line of your memory growing and growing, because every function call, every time is locked into the memory. But you can make an exact call tree per thread, per whatever. So you have all detail. And also a very nice function is, which you can use it for, is our trends. So you can, I have a nice demo, but you can see a chart of every function call is getting slower and slower. Other profilers only show the average of it. But sometimes it's useful to see some kind of line, some kind of trend of it, so you know what's going on. I haven't had the time yet to make a 64-bit profiler, so it's only 32-bit at the moment. But for a lot of problems I have to optimize, it's not a big problem to just to compile it for 32-bit, just to make a testing environment and test it on 32-bit, because when it's slow on 32-bit, it's also slow on 34-bit the other way. And the way how you use it is, I have a small function, a small file you can include, API function to load the DLL, also start and stop manually the profiling in your code, so you don't have to push the start and stop button yourself. Only when it's entering a special function, you know when it's entering this function, then it gets loaded, so you can't do it in your own code. So you have to change a little bit in your code, but you can also use the sampling profiler and then select the process and then say inject the DLL. It's a little bit like a virus, but at least it works. You can inject the DLL into a process and then you can select the function and start profiling. It's my first open source project 10 years ago, or maybe even, no, not more, but it's not very user-friendly, I'm afraid. It was a proof of concept. I had an idea, I tried it, and it was successful, and at least it works for me. some general profiling approaches you should use when you start profiling. Whatever profile you use, I don't mind if you don't use my profile, use whatever you want. But first, you mostly you try using a sampling profiling to get an idea what's going on. Just a rough, coarse-grained profiling overview of which function are called. Is it slow because of a database action? So you should look at your database index or parameters or whatever. And when it's after that and you can't get it fast enough, you try start instrumenting profiles. Then you look at the durations. Well, it looks easy to me that you start with the highest number of functions. At least the functions take a lot of time. That's where you start with. When you optimize a function that is uses 90% of the CPU time, when you make it twice as fast, you get a 35% performance boost. Not sure about the math, my calculation, but at least a rough indication how much faster you get. But when you have 10% function and you make it 10 times faster, you only get 9% improvement. So you really should look at those, the biggest, the slowest function. And when you do that, you try to iterate a little bit. You change something, then you do profiling again. In my previous example of the import, first it was slow because of the Excel communication. When you have eliminated that bottleneck, another bottleneck will pop up, which was the remember now anymore. Anyway, so you start iterating till you have reached a timing speed, which you think, okay, how much effort should I take more into it to get it faster? Is it efficient or not? It can take a lot of time to make it 10% faster, but if it's already good enough, then you stop. When you have a function, or at least a function that is called 90% of the time, or takes a lot of time, you can look at to make that function itself faster, or to look at the call count. When you have, for example, a loading function, you load an order and you load the order lines, and you see one function call for the load order, where you see 3 function calls for load order lines. Why is it called 3 times? You should only call load order lines once. So you also can eliminate the number of function calls. And yeah, when you really need more speed and you have to go, you can't optimize easily further, you should think about RAD architecture. You should make some less abstraction, a specialized function or whatever. In my case, it was a special function for some kind of import, which uses threading. I had to use a very different, direct, specialized function for it. Sometimes it's just needed, because the user doesn't care about how your code technically looks like. Just wants the fast application. All right, the demo again. Let's start using the same demo, but then let's see, the simplest function is this one. I first load my profiler to parses the map file and settings. You can get a little pop-up function here on top of it. Just a simple start button. You can select the items you want to profile. It parses the map file. And yeah, most time what I do is just select everything and just select everything. Don't use the profile itself. Of course, you can get weird results. Also, don't use, I should sort the list. Don't use some low-level system functions of Delphi, because you get crashes or weird results or whatever. because they are, I don't know why, but at least some kind of low-level functions. I also use some low-level memory allocation function in my profile itself, and sometimes they just collide with each other. And when we're done with it, we can press the start button and press the stop button when we want to. But you also can use the code in your, call the API function yourself. So in this case, I press the sleep button and just just add some code which checks if the DLL is loaded or not. And then when it's done, first time it takes some time. It's loading it's injecting all functions it has. So the more function you select, the slower it will get initially. When I press OK, it goes on, and then it starts profiling. This is the easiest, the best way to do it, because when it's done, it's also done. So I don't have to wait till it's done and then press the stop button. I will show a little bit of code of it. How I did that. So I just check if the DLL is loaded, then start the profiler, and anyway, it's whether it should ask or not. And then I call my function self with a nil parameter. It's just an ugly trick to use now this demonstration to get at least my button one click in the stack trace. And when it's done, I will stop the profile. Not this one. Just keep it. It's not easy to use. So I use this, and then I should watch the results. You can look for every thread, how much the time it has taken. I don't have a multi-thread demo in this case. First, you have a function overview. Well, you can see button one click takes most of the time. It's called once. It calls 10 times the sleep 1000 function, which calls 1000 times or 100 times the sleep function. So when I click on this one, this is the slowest. Now I should just start with this one. I can walk through the tree to see which function it has called. When I double click on this function, it jumps to that function, and so on. I can walk the trace tree to take a look at all the functions that are called. In the bottom you see some functions about the parents and child calls, how much time it has called, how much time it has taken, some average, minimum and maximum values. And here you see the chart. Well, it looks like a flat line, so it's constant. I don't have time to show everything, unfortunately. There are some interesting results with Ado. I don't know which people are using Ado for SQL Server or whatever. Or Viaduct, at least the T-Ado query is very slow. 100 calls for a simple execute function takes about 2 seconds, and when you do a low-level Ado call, it's first time it takes about 1,000 times, takes about 1,500 or 2,000. At least it is 10 times faster. And when you execute the low-level Viaduct function, it's even more faster. But now you have some overhead because I have the profiler, because it was about 300 milliseconds. It was Viaduct, the direct low-level Viaduct function was way faster. So it's the first time I tried to use Viaduct, and I'm really impressed about the performance. To show some trends, I have a hash list, the T string list, but then the T hashed string list, and I compared the T dictionary, the generic dictionary, and well, T dictionary is way faster. So when I look at the results, I get you see my button 6-click, and first is this hashed string list, which takes about 770 time of the CPU time, and the T dictionary takes 22. And when we look at the hash list, it calls, because I one couple of times I just do an index of, and when you do an index of and hashed string list, it does some kind of update hash value. And as you see, this is the one that takes a lot of time. And the resting part of it, when you look at the trend, you see, because I added function data to the list, to the list, and to the list, you see it grows over the time. So this is sometimes it can be useful to what's the trend. I don't have that much time, so I see if I can skip. Well, I have a list of some kind of tips you can use. One thing is when you have parameters, you don't change them, make them constant. When you look at the CPU window, the generate assembly code, you really see how much code it uses when you don't use const, and when you add constant parameter to it, it's really really less. Small tricks like when you have a memo or T-string list, use begin and update with the T-dataset, use disable enable control. You can use class functions, so you don't have to create an object, call a function, do a computation, and destroy the object again. Inline for small functions. When used for big functions, it can be even worse, it can get slower. Don't use variants, or least as possible, because it has a lot of overhead when you look at assembly. General database things are use SQL parameters. That's better for the compile time. A lot of other tips. Maybe use multi-threading, be aware with locks, just lock, fine-grained locks, just lock it, get the data and unlock it again, and then do the real processing. When you do memory of multi-threading and you have memory-intensive calculations, use some kind of other memory manager than FastMM. I have made my own ScaleMM memory manager. You also can use Google's TC-Malloc memory manager. This is way faster than the FastMM, especially in the memory-intensive calculation and multiple threading. Because with FastMM you see on the quad core you see only 25% CPU, so it doesn't use the 3 other cores. And the real low level is about data alignment and that kind of stuff. Some tools I want to show, or at least mention, is Process Explorer of Microsoft. It has a thread tab, so you can also watch the stack trace there, but you need some kind of debug information, Microsoft debug information. And you can, that's why I made my own stack viewer, so I could just use my own stack viewer to use this stack without converting the debug symbols. And I made a mini dump reader. I haven't put it in my demo, I don't have time to show it right now, but the main thing is when you have some kind of function or a service which is running on a production server and it's not reacting for some time, you can do some kind of checks for it. Then make a mini dump of it. Or when it's slow and you can do it with Task Manager, make a mini dump of it. Just a dump of the state and then watch the stack traces offline afterwards on your own computer. I can show this now. I just want to mention Intel vTune, which is really cool kind of software. I used it for my ScaleMM to profile it, to really get on assembly level to get how to optimize things. And really interesting how you can optimize something simple things because of data alignment, about the order of execution. the idea is the more chaos you have, the faster the CPU is. Mostly we try to order our computation, but it's better to do several kinds of computations in bad order, but the CPU can also execute all those functions parallel. So there's already some parallel processing in the processor itself. And one thing you must know when you look at it, I also tried the string test of brains lately, and I saw it was slow on one kind of loading the result in a data in a variable. But what you should know, it's not. It was waiting there because it was waiting for the result. It's like when you have an async or a lazy function or a future in Delphi present, you just start execution, but when you read the value, then it waits, and then you see the high CPU time on the line where it loads, when it reads the result value. That's one important thing you need to know. Unfortunately, it's very big and slow, and Delphi is not supported anymore. So it needs TDS to PDB. I have mixed results. At least Delphi 2010 it works, but with the newer versions, with the longer namespaces, it doesn't work anymore. I can't show the presentation of demo. I hadn't time for it to prepare it. Unfortunately, I couldn't get it working.
Chi è il musichiere? Hello. Okay, so this is the closing keynote. We are going to have the prize draw, and then we also gonna I have to give you some information. I promised to have all the slides here. This is a memory mistake, okay? But it turned out that it's not possible to have all the slides here because not all the speakers gave us everything. Non tutti gli speaker ci hanno dato tutte le slide. So you will have the key, you have the memory stick, avrete la chiavetta, ma c'è solo il catalogo, ho detto. But there is only the catalog. Inside you will have to download the slides. I'm very sorry, but yeah, we tried really hard. Okay, so let's start. Okay, the prize draw. There is one rule. If you are not here, you cannot get a prize. So you are here, so you will get the prize. The people who's not here will not get the prize. Okay. So we have a nice prize list. We have the 3-seat for training on mobile development with Delphi. It's a 2-day training. You can choose to have it in Rome or Milan, and it is offered by Big Time Software. Then there is one license of KBMMW. Middleware, thank you very much. From Blaise Pascal. Then there is RAD Software. I don't know if you remember last year there was Ray Konopka. This year I couldn't make it to be here, but he's still a sponsor in the conference, and he's offering the license for RAD's Component 6 and for CodeBase Studio 5, which is very nice product. Then we have the Stima software of the 2T chart professional VCL FireMonkey tools. Then Scooter software 4 license for Beyond Compare. Then Fast Report have one Fast Cube, one Fast Report VCL standard, and 2 bags. We have the bags. Yeah, show the bag. Inside the bag there is a gift. Okay. Then 5 Smart Mobile Studio license from Optimal. Okay. Then, okay, this is the first row. Okay. We have our very well tested FireMonkey application for doing the... It's VCL. Why? It used to be FireMonkey. It used to be FireMonkey, has been rewritten in VCL. Sorry. Okay. So we have all the names inside. Let's go for the first training. Giuseppe Garzotto. Okay, you want the thing? Now, thank you very much. Valentina. Where is Valentina? Okay. She's writing your name. You will receive an email for that. Okay. Then we have Marco Cirinei. Where is it? Marco? He's not here. So, he will not get the prize. Oh, Massimiliano Coros. Okay, you want the other seat? It's 3. Jarle Helmut Thun. Where is he? He's left. Okay. Go. The rule is pulling again. Paolo Fainelli. Paolo. Okay. Segnalo i nomi? Okay, thank you. Now, 2 licenses for the middleware. Okay. 2 licenses. First license, Carlo Narcisi. Carlo is not here. Go ahead. Now. Eric. The left. The left. Price. Stefano Busetto. Ok. Sarebbe bello se if they can shout bingo. Go, 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 go. Andrea Valenti. Andrea Enrico il middleware. Then one license for the enterprise version, which is better. Omar! Oh! Adesso, Rails Component 6. Vediamo chi vince? Io non vinco niente. Marco Orsenico. Non c'è. And Maurizio Del Magno. Let's go. Ok, allora.
Figliolo che ha vinto, avrebbe vinto.
Ok. Walter Procopio. Non c'è. Let's go. Too late. Peter. Ok. Right name.
Next one is
Rates Code Site Studio 5.
Goes to
And the winner is Luca. Minuti. Ok. E adesso abbiamo
Stima Software.
2 T-Chart Pro from Stimasoft. The first one goes to Massimiliano Spinetti.
No.
Let's go. Ma è parente, non si sa di Spinetti, è parente. Andrei, he's gone. He's gone. Questo è il primo. Pierpaolo, oh, hai vinto Cozzai. Questo era il primo, sì, era il primo. Valentina, ci confermi, era il primo solo? Ok. Luca Rossi, ok. Feature Pro, questo.
Scooter Software 4.
For Beyond Compare from Scooter Software. Go, 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 go.
First one.
Dai, alla fine usciamo tutti. Roberto Garzon. Ok.
Secondo.
Thomas. Terzo. Antonello Laiano. Ok. And for Rolando Del Piazza. Ok, ecco. Fast Cube Standard from Fast Report. It goes to Antonello Carmagno. We have Master VCL Standard. Simone Giacomelli. He's gone. He's gone. Gerd Berg. Left. Left. Pietro Nuvolo. Oh. Pastorello Polizia Standard. Then the two bags. We can deliver the bags right now. Yes, the Valletto is Marco. Okay. Goes to Franco Peran. And the second one goes to Marco Moncina. Okay. Grazie al Valletto Marco. Okay, five Smart Mobile Studio license. We have 5. Number 1, Michele Manara, Smart Mobile Studio. 1. The second one, Andrea Lollobrigida, è andato via. C'era, ma è andato via. Stefano Pisianeschi, eccoli. E sono 2. Go. Mirko. Ok, number 3, go to Mirko. Sara. She's gone. Renzo Cleotti, number 4. This is the 5th one. Number 5 goes to Marco Mariana. Okay. We have a special offer for all the attendees of ITDevCon. You can get the 50% off for a few more days on SMS Enterprise version.
Smart Mobile Studio Enterprise version.
Yes, Smart Mobile Studio. Yeah, just send us an email or contact Daniele or Valentina or anyone else from our sales team, commerciali, commerciali, and you will have the 50% off on Smart Mobile Studio. Okay? So the memory sticks. Valletto, aiutami. Okay. Yeah, we need to distribute this. Jerome is also offering this for your pleasure. Dai, dammi una mano. Vediamo un pochino in giro. Sì, a tutti quanti, guarda. Vediamo così. Riusciamo a fare. Cercate di non prendere i doppi perché mi sa che non ce l'abbiamo troppo. No, proprio io. Se no, chi non ci arriva gli diamo i biscotti.
E poi volendo c'è esatto, non si serve i biscotti.
Grazie. C'è mano, ok? Come? I biscotti? Sì. Volete i biscotti? Marco, come balletto però, mi passi così. Biscotti? Come vuole adesso? Andiamo un biscottino adesso. This is Dutch. Vabbè. Yes, you can get it. Okay, next slide. Okay, if you enjoyed the conference, please blog and tweet about it. It's very important to be on the social media. We want to be there. If you really enjoyed, please talk about ITDevCon because next year is going to be even bigger. Okay? Thank you very much. Obviously, if you didn't enjoy it, don't say it to anyone. Just keep it for you. No need to tell other people. Okay? Thank you very much. And have a great day home. And see you next year.